morning, everyone. This is Mark Collier with the OpenStack Foundation, and I'm going to be your MC today along with, you might be on mute, Ashley. So Ashley's going to join us. Introduce yourself.
Hi, I'm Ashley Ferguson. Yes, I was on mute. Sorry about that. Welcome, everybody. We're glad you made it.
Yeah, so we're really excited. This is the first time we've done this particular event as a virtual series. And, before we kick things off, we just wanted to give everyone a couple of minutes to get logged in and adjust their settings, and just going to ask you a quick question. And, one of the things we're going to be using today is the chat function in Zoom. So if anyone wants to let us know in the Zoom chat, is this your first OpenDev? Let me know, and maybe we can hear a little bit about everybody. And then in just 1 minute, we'll be kicking things off. All right, looks like people have discovered the chat. It looks like Wes is his second OpenDev. Yeah, looks like we have quite a few new folks. Awesome. Well, I think we've got a lot of people logged on now. So with that, I'm just going to go ahead and kick it off here. So this OpenDev is all about open source used for infrastructure. That's what this series of events is about. We have 3 of them. This week's event is really focused specifically on large scale usage of open infrastructure software. So all that great open source software used at massive scale, the issues, the challenges, the best practices. So we have so much great content to share with you, a lot of conversations where everyone can get engaged and we can really move the ball forward on open infrastructure. And so to tell you a bit about how we're going to be collaborating through Zoom today as our meeting tool here for the event, I'm going to turn it over to Ashley to tell you how to participate.
Thanks, Mark. Yeah, we're really excited to get started here. So a couple things to mention up front. So let's talk about how to participate. We've done OpenDevs in the past, and they've been really great, thought-provoking, discussion-oriented, collaborative events that focus on solving open infrastructure challenges common to everybody, and we'll talk about solutions to those problems here. So congratulations if you made it here. You made it to Zoom, which is one of our main tools we're using obviously today. And then the other tool is called an Etherpad, and we'll get into that a little bit more later. Okay, so back to Zoom. If you have a question about the current topic we're on, Mark already mentioned the chat, so feel free to hop in there. If you have any questions along the way, feel free to jump in there, ask a question. Obviously, there are tons of people on here right now, so we will do our best to answer all of those questions. And then you'll also see the mute function, just as a courtesy to others speaking, make sure you're on mute just to cut out on any background noise. Obviously, this is a virtual event and everybody is adjusting to virtual events right now. So just to help it go smoothly, make sure you're on mute, double check that every now and then, and things will go great. Okay, so back to Etherpads. So Etherpads are an open source tool that we use for real-time notes, collaborative feedback, action items, just taking notes on the conversation and focusing the discussion. So our moderators will be watching those throughout the discussions, asking for feedback on certain topics, or they might drop some questions in there. So feel free to hop in and answer those and interact with us. And I think Aaron is also dropping a link into all the Etherpads that we have. We'll have 1 per session. You can also head to the online schedule and we'll have links to all of those sessions, Etherpads in there as well. And of course, if you need help with anything during the event, if you're having login issues later in the week, again, this event is Monday, Tuesday, and Wednesday, feel free to email events@openstack.org. And if you're already in the chat in Zoom, feel free to drop a question in there, like Mark and I mentioned. And then you were also emailed an Etherpad that has some tips and tricks to help you have the best experience. Like I said, this is the first time we're doing this event virtually, and so we just want to ensure that everything moves smoothly and everybody gets the most out of their OpenDev experience. And then as a friendly reminder, this is an OpenStack Foundation event, so we do abide by the OpenStack Foundation Code of Conduct. So just as a reminder, that just means be courteous, conduct yourself professionally, And please respect each other. And if there's something that you need to report as a code of conduct violation, you can head to that URL at the bottom, openstack.org/code of conduct, and that'll have instructions on how to do that there. And now I'll turn it over to Mark to introduce our amazing programming committee who helped make this event possible.
Yeah, thank you. And I have to say, as people have been joining, we have people from all over the world: Australia, India, Brazil, Nepal. It's really incredible. I think we had someone from Australia, Paris, even Texas. So we've really got the world participating. It's what we love about these events. And this particular event this week was made possible by our programming committee. I mean, these folks worked really hard to pick out the specific topics that we are going to dive into, that are going to be moderated in each session, that all fit within this large scale open source infrastructure theme for the week. And so I just want to thank everybody here, Allison, Belmiro, Beth, Masahito, and Roman. They all put a ton of time and effort into it. So thank you to all of them for their efforts. And some of them will be moderating sessions throughout the week as well. And next, I'd also like to do is go ahead and thank the sponsors. So all of the companies that made it possible for us to put this event on, that provide us financial assistance, funding for everything we do, and that includes this event. So thank you to all these companies for your support for the mission that we're pursuing here today and this week. And with that, I'll like to turn over next to the Executive Director of OpenStack Foundation, Jonathan Bryce. Take it away, Jonathan.
Well, thank you, Mark and Ashley. It's great to be able to add my welcome to everyone. This is our first virtual OpenDev. It's very exciting to have everyone working together over the next few days. This isn't necessarily how we plan to do this event, but I still think it's going to be great to have everybody collaborating here. And some of you might have been in Denver a year ago. I gave a keynote there. And at that keynote, I talked about a music project called the Silk Road Ensemble. It was made up of musicians from a number of different countries, and they were bringing their cultures and their instruments and their style of music all together to collaborate and create kind of this new set of music and performances that they were doing together. I also, in that keynote, I showed this photo from one of our PTGs in Denver, where we got our community from all over the world to come together. There was only one instrument; it was a piano, but everybody brought their wigs and their personalities, and this is one of my favorite examples of what we've done in our community, where we've come together and collaborated in our own ways. So the point that I was making in all of this is that these examples of these people coming together, they were showing a collaboration without boundaries, and that kind of collaboration, where we work across communities and countries, companies, languages, time zones, cultures, that is so powerful. What struck me though is, as I was thinking about it this week, I was giving that keynote to a single room of people in a single city, to a subset of our community that had been able to travel to Denver and attend that event in person. A year later, we all know that the world is very different in many ways. The original plan for this week was to actually have this event co-located with a PTG in Vancouver, British Columbia, Canada. And I love Vancouver. I know many of you do as well. It's one of our most successful and favorite locations to have events. And I love getting together in person for those events. But we aren't able to do that right now. However, the collaboration can continue. This is the first virtual OpenDev that we're doing, but we recently coordinated another virtual event series for our developers, and that was for the PTG. The PTG is an annual event that actually we've done it twice a year in some years, that we've done for a number of years, and normally we've done that in person. Some of you may remember OpenStack. This was a couple of years ago in Dublin, when the snowstorm of the century hit and we were all trapped in a hotel. So that might have been too much in person for some of us. But it ended up being a really great event in Dublin and building community. But what I thought was interesting is, when we just had our first virtual PTG, we had more participants from more countries and more organizations than any other PTG. And we also saw an increase, a small increase, but an increase still in the percentage of women who were participating in that PTG. So, while we weren't able to get together in person, we still got our community together, got our developers together, collaborated. And even in this new and very different reality, we actually were able to come together and make important progress and do that collaboration without boundaries. And, like I mentioned, there are some benefits to this. With these virtual events, we saw new attendees, new participants, people who were engaging that hadn't been able to engage before. So removing those barriers to participation, that's awesome, and I think that for this event series that we're kicking off, OpenDev, this is an event that's all about collaborating without boundaries and doing that in the most inclusive way that we can. So before we get started, I want to make 2 points before we dive in. The first one is, as we get started this week, think broadly about the topics that we are addressing and the ways to solve them. I mentioned, being inclusive in our event style, and I want to be inclusive in our mindset too, not exclusive at all. Let's think about real solutions that span multiple projects, multiple communities as we work together across organizations. And let's try to make our discussions mirror that attitude of inclusivity as we try to bring together the best ideas to kind of get leads on how we're going to solve big problems. This event, it has a lot of participation from the OSF community and the OSF projects, but it's definitely not just about any single project and any single community. If we look across the open source landscape, Mark mentioned, this is about large scale usage of those tools. And if we think about the tools that are out there, people are using all of these projects together. People are running hundreds of petabytes in Ceph. They're running thousands of nodes in their Kubernetes cluster. They're using Prometheus to track tens of thousands, hundreds of thousands of metrics per second. And OpenStack, we have users who have millions of cores in their OpenStack environment. So when we think about large scale usage, this is a challenge that spans projects all across the open source ecosystem. And for the operators out there, that you are trying to put all of these tools together and scale them at the same time. And that is the heart of what we want to get to this week. So this OpenDev event started as a much smaller event a few years ago in San Francisco when we had our first OpenDev Edge that was focused on edge computing and defining what cloud computing meant on the edge. So this was an event that we had about 200 architects, developers, users come together and spend several days tossing around ideas. What was really valuable about that was not just the work that happened during the week in San Francisco, but it was about the progress that continued after that week. And if you look at the things that have happened since then, that edge computing group that formed up in 2017 is still collaborating to this day. They've been to PTGs, they've been to open infrastructure summits, they have continued to work together to define what cloud computing means in the edge. And just recently, I think last week, released a second edge white paper that goes into architectures for edge computing. So here we are 3 years after the event, and the work that started there is still happening and still continuing from this group of people that met during that week. This edge computing white paper, you can see it at openstack.org/edge. It's really valuable because, again, it takes that approach that I'm talking about, where it's talking about architectures, it's talking about use cases, rather than saying this particular technology in this format at this time. It's really defining a whole solution across a broad set of technologies. So that's what OpenDev is all about, thinking broadly and bringing it all together. So I think the other point that I want to make is just going back to collaboration and to the opportunity we have this week. Collaboration is made of people, so to speak. I've been talking about technology and projects and use cases, but nothing collaborative happens without having people involved in it. And that might seem kind of obvious, but I think that it's important for us to keep in mind as we start this virtual event. When we're in person, it's easy to have those kind of serendipitous interactions where we run into someone in the hall and we have a chat. I think that one thing that we should keep in mind this week as we have our first virtual OpenDev is to make sure that we are all engaging. Whether you're talking about a music group or an open source project, none of it happens without people coming together. And that's what this week is all about. In just a few minutes, we're going to get started. We have discussions throughout this week. In a little bit, we're going to have some presentations to kind of level set from some users in the community. And we're going to be hearing from Blizzard and OpenInfra Labs and Verizon. And these are all experts. And we have moderators who are experts from CERN and Line and 99 Cloud and Stack HPC and others. But ultimately, what is very important to making this event successful is the participation of all of you who are here. I mentioned that our virtual PTG was our largest PTG ever. And this OpenDev event that we're doing virtually is already our largest virtual OpenDev ever. But remember, it's not meant to be you here as an attendee. Join the discussion, join the conversations, use the Etherpads, put your questions in the Zoom chat. We want to hear all of the feedback. We want to get those discussions going in a very interactive way so we can all share our knowledge, share our experience, and be able to learn from each other. This isn't a conference that's filled with presentations. I mentioned we have a couple this morning, but the rest of the week, it's all about discussion and moderated interactive knowledge sharing. So the goal is to share and learn from each other and identify work that we can carry forward beyond this week. So collaboration, it's made of people, and this week, we are those people. To give you a little bit of a view of how this is going to work this week, today we have a handful of sessions that are getting kicked off with some user presentations, and then a moderated session led by Belmiro from CERN. We'll have more moderated sessions tomorrow and Wednesday as well. And at the end of the day on Wednesday, we'll do a recap of the week where we can decide what we should do, how we should carry it forward, and keep the work going to keep solving large-scale usage issues in open source projects. There's also a large-scale SIG for OpenStack. That's an example of the kind of thing that it might make sense to get involved in beyond this week if you want to work on scaling challenges in OpenStack specifically. So, the large-scale SIG is a great example of something that exists, and that'll probably be tied into where we go from here. But as we go through the week, we may discover other things that are really useful. This is also the first in a series of events. As I mentioned, the original plan was to have this event in Vancouver, and we were going to have all of these tracks there in Vancouver along with the PTG co-located. Since we had to do it virtually, what we decided to do is to break out all of those events into a series. So we had the PTG a few weeks ago. We're doing the large scale usage this week. In a few weeks, we'll be doing hardware automation, and then after that, containers and production. These events are all the same format. It's all about getting people together, meeting each other, and making those connections so that we can continue that collaboration on an ongoing basis. So before we get started, just wanted to kind of throw out a couple of ideas. Let's think broadly, think across all of these projects and communities and how we can get working together. Also think about not just what we do this week, but what we do for years to come as we collaborate. And remember that collaboration requires all of us to get involved, to share what we have to offer, and to engage. So I'm really excited to see how it's going to come together this week. Been blown away by the level of interest that we've had. It really exceeded my expectations. And I'm very happy to have all of you here joining with us to participate. So I'll hand it back to Mark and Ashley.
All right. Awesome. Well, thanks, Jonathan. We're going to have a couple of sessions today. The first one, as Jonathan mentioned, is about the users and the user stories. So I'll be kicking that off shortly. And then after that section, we'll have a short break followed by the upgrades session. This is always a hot topic. A lot of work goes into upgrades, and certainly CERN has probably done more upgrades than anyone. Belmiro is going to be an awesome person to lead that. And I will also just ask, not just for my benefit, but for Belmiro's, to listen to your moderators. We have a lot of people joining by Zoom. This is a new thing to have it, to try to do collaborative sessions by Zoom. So we're going to be experimenting here and trying to get people involved as we go along. But the moderators today and throughout the week will be trying to guide those discussions and get people engaged as we go. And so throughout the next sessions in the week, we're going to have both Tuesday and Wednesday a number of sessions, and these are all part of course, the large-scale open source infrastructure theme for this week. But diving into specific topics, we have amazing moderators for each of these, and you can actually go to this link here. We'll drop it in the chat, which has the schedule for the week, not just the schedule and the topics, but links to each Etherpad. As Ashley said earlier, the Etherpad is a very important tool as we do these collaborative events. Many of you have probably used it before, but if you haven't, it's a bit like Google Docs, collaborative editing. And so each of those sessions has their own Etherpad. You can even see some of the pre-work that's gone into it. You can start to contribute or participate or just kind of do some homework before we get to these future sessions. So again, this link here that we're dropping in chat has the links to all the Etherpads, and you can learn more about each session, plan your time accordingly this week. And so with that, what I'd love to do is get started with our first session. Now, as Jonathan said, the event is meant to be highly collaborative. And as we get to upgrades and the other sessions throughout the week, we're going to have things will become more roundtable style. There'll be more opportunities for people to unmute and join the conversation. But for this first session, we're going to do it a little differently in that, everything we do with open source is for the users. We fight for the users. That's our true north. So to kind of give us some context before we dive into each of those topics, we want to actually hear from 3 amazing users. These users are going to tell us a little bit about the day in the life of a user trying to run massive scale for these critical operations for their business or their research efforts or whoever they serve with open source. So we're going to hear presentations for this section. We'll have about 5 minutes of Q&A after each user. And we're going to do that Q&A through chat, the text chat. So if you can put your questions in the text chat, I will read out a few of them during that 5-minute section after each user speaks with their slides. And then the rest of the week, it's not really going to be about presentations and slides. It's going to be more roundtable style. But we thought, since all of the work we do together collaboratively as people, as Jonathan says, is about how do you actually run it in production by hearing from users that are running this stuff in production, what challenges they're having. That'll help kind of frame our thinking as we head into the week, talking about upgrades and all the other issues that we're going to dive into. So to kick us off, the first user is from a company called Blizzard, you may have heard of, and they have some incredible, I would say very mission critical infrastructure that the world is relying on more than ever now that we're all at home. So to present and tell us about their use case and some of the challenges they've had scaling, I've got Colin and Eric from Blizzard. Take it away.
Morning. Hi, Mark.
Morning.
Are we able to?
Yeah, we should be able to make you a co-host so you can screen share.
Excellent.
Yeah, once you're a co-host, you should be able to take over the screen share. And believe that we're pointing and clicking as we speak.
Excellent.
So while we do that, let me see, tell you a couple other things. We're going to have after Blizzard, we're going to be hearing from OpenInfra Labs, which is, I don't want to steal their thunder, but an amazing collaboration. And, we're also going to be hearing from Verizon, which is one of the largest mobile carriers in the world. And they're talking about some of their testing work. So are we?
I'm just waiting, still waiting here to, I've got things ready to go this end.
Okay.
As soon as I'm co-host, I'll get us started.
Okay. Yeah, it looks like we might be having an issue with the co-host feature.
Oh,
so
okay.
we may have to call an audible here.
Here we go. It's okay.
Okay.
Just got it now. Let me.
All right. Awesome. Working through the kinks. Okay. Let's hear about Blizzard.
All right. Can everyone see this? Okay. Is that showing up, Mark? Okay.
Yeah.
Awesome.
Yeah, we're getting both two slides.
Swap your screens.
Swap my screens.
Yeah.
You bet.
Yeah, it looks like we're seeing
Go to
Good
the
job.
top six. Yeah.
One second.
Where it says swap displays. Third button over on the top left.
There you go. Thank
Beth
you.
is already diving in and helping.
There she goes. Awesome.
You'll get to meet Beth very soon.
Excellent. All right. Well, good morning, everybody, and good afternoon. We're connecting here at 6:30 a.m. from what would be a sunny California. So just to do quick intros, my name is Colin Cashin. I run cloud engineering at Blizzard Entertainment. I'm also joined by Eric Anderson here, who leads one of our cloud engineering teams focused on OpenStack. So I'll present today, but Eric will keep me honest during the Q&A, as he and his team are the true experts in the technology. For anyone who doesn't know, Blizzard Entertainment is a developer and publisher of entertainment software with some of the world's most beloved game franchises, including World of Warcraft, StarCraft, Diablo, Hearthstone, and Overwatch. And we are dedicated to creating the most epic entertainment experiences ever. All right. Here we go. So just to give people a quick overview of cloud and multi-cloud at Blizzard. So our cloud powers all of these entertainment experiences, and our strategy is multi-cloud. So we operate private cloud and we consume multiple public cloud providers, including Amazon, Google, and Alibaba. We own and operate an extensive global private cloud platform built on OpenStack. This involves over 12,000 compute nodes across 13 co-location facilities in the 4 regions we operate our games in: the Americas, Europe, Asia, and Australia. Our deployment is somewhat unique in that we operate a single production deployment globally, with globally replicated instances of Glance and Swift and pseudo-replicated Keystone. After a period of development and staging, which begun around 2012-2013, our private cloud went into production in 2016, ahead of the global launch of Overwatch. Since then, we have integrated 13 projects into our cloud, providing for all the common infrastructure primitives that our game and platform teams use to deploy applications and store data. In general, we value simplicity over complexity, so much of our cloud is simple. For example, we use Linux Bridge for networking over SDN driver. In Q4 of last year, we completed an upgrade project to get to Rocky release across all our environments. This was a huge undertaking as we moved 5 releases in one jump. It's Mataka to Rocky. I think most people appreciate the magnitude of that. So we continue to contribute upstream, and we're intimately involved in the Designate and Sandlin projects. Eric Anderson drove a major cleanup of Designate, and Duc-Tru Wang was PTL and core reviewer for Sandlin, helping drive the reliability and scalability of that service. Blizzard gave a talk at the Denver Summit last year, so if folks want to take a look at that, we highly encourage it. In supporting a large scale and heavily distributed cloud, we've hit many issues around scale. And today we're going to talk briefly about 4 that are nearest and dearest to our hearts. Scaling challenge number 1. So Nova scheduling with NUMA pinning. In order to guarantee compute performance for our high-performance game server workloads, in particular Overwatch as a first-person shooter, the decision was made in 2016 to implement NUMA pinning during scheduling, as we use multi-socket systems. This ensures that guest VMs are not scheduled across NUMA zones, exposing memory bandwidth bottlenecking for computational heavy workloads, ensuring that the penalty of crossing oversubscribed bus interconnects on the silicon die are avoided. Overall, this caused a lot of pain at scale. NUMA scheduling is expensive and it requires a read call to NovaDB. It's all impacting the turnaround timeliness of the process. During large deployments, where teams may deploy hundreds of instances simultaneously, we regularly ran into race conditions whereby scheduling would fail as the same small set of computes were targeted and the scheduler trod on itself. This was tackled by some configuration tuning, whereby the target pool for the scheduler was increased from 1 to 20 computes. For each new request, the scheduler would randomly pick one. Another side effect of NUMA pinning over the last few years was broken live migrations, now fixed in trains Nova release. Operationally, this affected our ability to drain compute nodes during maintenance events, and often we have to do this at scale. The takeaway here is that for large environments, NUMA pinning should be implemented in a tested and controlled manner, and that live migrations with NUMA profiling is fixed in new releases. Scaling challenge number 2, scaling RabbitMQ. RabbitMQ is the advanced message queuing protocol compliant message broker used to exchange messages and act as a broker between OpenStack components. The biggest challenges with Rabbit at scale are recovering when something goes wrong. With a large-scale infrastructure event, for example, a transient data center network outage, Rabbit can be overwhelmed with connections and messages. To tackle this, Blizzard tuned Rabbit configurations to introduce extended connection timeouts with a variance to allow for a slower but graceful recovery. Additional tuning was applied to Rabbit queues with policies to ensure that only critical queues are replicated across the cluster and that queues cannot grow exponentially during these events. We consider anything that is a one-shot message to be critical. So a VM create or VM delete event is handled by the compute queues and it's not an RPC call, so these are always replicated. For fire and forget messages, some notifications are critical, and we have a very high limit, for example, DNS, but others such as inventory notifications, a very low limit since inventory has support for polling and will recover even if a message is lost. Takeaway here is that Rabbit needs tuning unique to your environment. Scaling challenge number 3, neutron scaling. As a result of various operational incidents that were protracted because of having certain OpenStack services co-located on the same controller hosts, in 2019, Blizzard migrated Neutron RPC workers to virtual machines to scale horizontally and also solve for shared fate of the API and the worker pool. The Neutron API itself remained on the controller nodes. So by default, Nova queries Neutron every 60 seconds from every compute node to refresh all of its instances networking information. Then updates the Nova DB with this information. If the cache is not updated, the metadata service and Nova API endpoints will be proxying incorrect data about the instances. At the scale of 1,000 computes per availability zone in a region, this load can overwhelm the control plane, even on substantially high-spec controller hardware. After much research and conversation in the community, I was excited to extend this interval to between 4 and 5 minutes. This reduced load on the control plane from hundreds of thousands of requests per minute by up to 75% during normal operations. Additionally, each Python worker was tuned for 8 gigs memory usage just to take account of slow garbage collection. Moving to VMs allowed for sideways scaling on Neutron worker pools and solve for shared fate of API and workers. Takeaway here is that Neutron configuration and deployment should be carefully considered as the scale of your cloud grows. Scaling challenge number 4, compute fleet maintenance. And so while not a scaling challenge directly related to OpenStack itself, this area of concern has challenged us for some time. As our private cloud went into production at scale, there was an internal drive to migrate more workloads into cloud from bare metal. In a lot of cases, this meant migrations took place before applications were truly cloud aware. Over time, this severely impacted our ability to maintain the fleet and target compute host OS and firmware upgrades in a timely manner. Progress involved lots of SRE toil and did not scale. Over the last 15 months, our software team has built a new product, Cloud Automated Maintenance, that enables automated draining and upgrading of our fleet using Ironic underneath to orchestrate bare metal and a public cloud style notification system with automated lifecycle signaling. You can set a golden version of OS and firmware bundles, and the system will cycle through the compute aggregates in each region until everything is compliant. Our goal is to reach a 6-month cycle time for our global fleet. Takeaway here is onboard tenants to OpenStack with strict expectations set about migration capabilities, particularly for less ephemeral workloads. Also have the processes and/or system in place to manage fleet maintenance before entering production. Quick side note, Blizzard Cloud is hiring. We have engineering and leadership positions open in our California office in Irvine and in Texas in Austin. And yeah, if any of these challenges sound interesting and working at scale on some of the best video games in the world sounds interesting, please hit us up at careers.blizzard.com and search for cloud.
Awesome. Thank you. Well, that's amazing. A lot of great detail there on what you did to scale up. And we've gotten some great questions here in the chat. So Mohammed Nazar asked, I'm curious what the control plane split looks like on Blizzard clouds. We know RPC runs on separate VMs, but what about the other components such as database, RabbitMQ, Nova, Etsy, et cetera, APIs?
So I'll take that one. So it varies a little bit depending on the region. Some regions are larger, some are smaller, but the general split is we have 2 to 5 dedicated control nodes for Nova, Neutron, designate, and then Rabbits and MySQL all both have 3 to 5 nodes, again depending on size. We also have separate nodes for Keystone and Glance. So in general, one region of OpenStack deployment would have two nodes of Keystone, 2 Glance, would have 2 to 5 for Nova, Neutron, Designate, and then like most of them have 3 nodes for Rabbit and 3 for MySQL. But again, we scale that depending on the size. So some of the really large regions might have up to 5.
Excellent. So we had a question from Beth. How closely are the applications tuned to the environment?
You want to take that one, Colin? Or
yeah, that's a good question. Tuned to the environment. So I mean, Beth, just to kind of dig in a little bit more there, you're talking about the actual underlying hardware in a specific region.
It's actually tied into what I'm going to be talking about, which is that it's an environment that you control the applications and you control the underlying OpenStack infrastructure. So how much are they tied together?
Yeah, so they're pretty tightly coupled. As we originally deployed cloud, we had a generation of silicon in the data center, which kind of obviously reflected the year that it went into production, and it's not typical to refresh that right at maybe the pace that you would be exposed to within kind of a large cloud service provider or public hyperscaler. So things like clock speed, things like the actual like network and storage I/O that you can achieve is actually quite static over time, versus maybe the experience you would have in public cloud, where you can deploy new instance types on new silicon and get those benefits quite quickly. So the applications would the performance characteristics for applications and for data would have been quite static over time, and we get these step increases when there's a refresh or a new environment or a new region is built, and we then things need to be re-benchmarked, and we work closely with our game and platform teams during those cycles.
Awesome, thank you. So I think we have time for one more question. So the last question I wanted to ask from John Garbett, which was if your fleet maintenance tool has been released openly.
Great question. So we, I guess that's TBD. We've had that conversation internally. The majority of the code base is in Golang, so it's a little bit different than the I guess the Python world of OpenStack, but we do interface with Ironic, as mentioned. Some of it is a little specific to the internal tooling within Blizzard and some of the more bespoke internal systems. But as it's nearly code complete and we're hoping to start onboarding our initial kind of internal customers towards the second half of this year, we're going to put it through its paces, see how it performs, and we'll make a decision on that in the future. So no plans yet.
Yeah, I have to add though that we have contributed back some fixes relating to this. So we, as an example, we helped fix the metadata part of CloudInet for Ironic. Just so we do try to contribute back at the very least anything that involves directly OpenStack components.
Yeah, that's great. And if we had more time, I was actually going to ask you about how you move from being just a consumer to more of a contributor. I know that Blizzard does make a lot of contributions, so I think it's very important to point that out. Doing a lot as a contributor in the community, not just using the software. But unfortunately, we're out of time. But I think there's going to be a great event where invite everyone to continue to participate from Blizzard, and hopefully any questions we didn't get to can be answered in the Etherpad. They're being added to the Etherpad. If you want to jump in there and answer them, that would be great. So next up, I want to introduce our next users. These folks are from OpenInfra Labs, and they're going to tell you all about their mission, their cloud, and some of the challenges that they've had. And I just want to say again, thank you to the Blizzard team for joining and for participating this week. All right, Michael and Bill, take it away.
Hi, I'm going to share my screen.
All right, we're off to the races. Thanks, Michael.
And tell me if after I just hit present, it's still visible and to everybody.
Yes, so you're You're not in full screen mode, but you are, but we can see the slides. So.
Okay, cool. So really basic question. OpenInfra Labs came out of a project that was started by a group of research universities in Massachusetts. And there's a really simple question there. Why did a group of research universities want to build an open cloud? And basically, it started in about 2010, 2011. It was becoming pretty clear that the cloud was here to stay. And aside from things like lock-in and cost, this presents a very special kind of problem for cloud researchers. If you can't see the data about how the cloud is behaving, it's really hard to do research into cloud behavior. A group of researchers in Massachusetts had this really crazy vision. Let's build one. It didn't need to be a huge one, just one that was large enough to get real users doing real things.
Mike?
Yep.
Your slides aren't advancing. I think you're showing the wrong window.
Let's see. I will skip the, I'll just show this one then. So this was the one that I just spoke to a second ago. Basically, it's about access to real data, real users, and scale.
You're not sharing.
There you go.
Okay.
All right, looks good.
Sorry about that.
No problem.
So we wanted to foster a marketplace model where new services could evolve. And we wanted a place for researchers, open source developers, and companies to test new things. Since 2013, we've enabled research and publications on cloud security, performance, new operating systems. And this experimental cloud that we built basically out of baling wire and duct tape is being used and depended on by services that support thousands of users. And it inspired Boston University and Harvard to start work on the New England Research Cloud, which is going to provide something similar to the MOC, but actually have SLAs, support, facilitators, more than 3 or 4 people answering the phones, basically. It's also led to a group of interrelated initiatives. The Mass Open Cloud, which I just spoke about. The Open Cloud Testbed, which is based on the work of cloudlab.us. It's basically moving work that we've been doing on Elastic Secure Architecture that's in the process of going upstream into Ironic into the National Testbed for Cloud Computing researchers so that we can move hardware around within the data center depending on where it's needed. One of the striking things about Cloud Lab is, not really striking, kind of obvious, is that the 2 weeks before any national paper deadlines or international paper deadlines, usage goes really, really high, and it's very low the rest of the year. The New England Research Cloud, which I spoke a little bit about already. Open Infrastructure Labs, which is a community that's designed to create a standardized, reproducible, and federated open source cloud. And the Operate First initiative, which was introduced by Red Hat at their summit, which is an open initiative to take operations and make them more open source. But this is supposed to be a talk about user stories, and we have lots of really good stories. I want to focus on the one that brought the MOC to the OpenStack Foundation and to the creation of Open Infrastructure Labs, Chargeback and Showback. We basically needed 2 reports. Our MVP was very simple. We had 5 member universities, and we needed to be able to show the researchers how valuable we are to them. So we wanted essentially who the lead was, their email, their compute usage, their memory. These are not particularly demanding reports, we figured. And the second one had a similar MVP or user story associated with it. Can we show the universities how valuable we are to them? And the reason that that mattered was we wanted their help. We wanted their money. We wanted their resources so that we could do even more. It ought to be simple. I'm not going to tell you about all the wrong paths we went down, the things that changed between versions of software, or the bugs that we were among the very first to find out. I'm just going to tell you what you all already know. Ceph captures data in one place, OpenStack in another, containers in another. It turned out these simple reports were not so simple. Another use case that we ran up against, onboarding new users. The number of potential users at the 5 partner universities is roughly the same number of people as there are in Iceland, several 100,000. It was pretty clear we wanted onboarding automation. We didn't find anything that was built to onboard users of VMs, containers, different types of storage, et cetera, all rolled into one. So we've been building it. Monitoring, another fun use case. There's what you need to have on day 1, there's what you need to have on day 99, and then there's what you need to have on day 999. While clarity exists in user forums and on Stack Exchange, well, not really, but it sort of does. There weren't a lot of examples that we could take and put into a production for the kind of customized clouds that most of us build. To a great extent, everybody's building these bespoke clouds, and it's really hard to monitor that. So what did we need in broad strokes? Better user management, single sign-on, simple would be good too, billing and invoicing, metrics and reporting, monitoring, and we were very committed to doing all of this in the open, not just the configuration, but the day-to-day system admin. We wanted that in a way that others could reproduce it. The problem, if you're an operator, is that the open source community scratches its own itches. And generally that does not include deploying a cloud that you're charging for. So it was driving us nuts. We spoke with our core partners and heard similar pain. We need a place to capture recipes that we know work. We need a place to identify user stories which cross project boundaries so we can share solutions. We need a community of operators. So we talked to the OpenStack Foundation, and we very quickly realized that we were preaching to the choir. Let's face it, the folks at OSF are way more succinct than I am. So in their words, the many-to-many relationships in open infrastructure today poses an integration challenge that can make open source options less attractive than proprietary choices, which are more turnkey. In discussions, we identified what the last mile for open source software might look like and focused in on the goal of creating a home for opinionated open source stacks. We described where we felt things were headed, and we're incredibly excited about this shared vision for the future. Here's what we've been up to make the vision a bit more real. We started almost, I guess, 8 or 9 months ago, last November, December timeframe. We've moved to GitLab to be more accessible to the operator community. We've got open cloud monitoring requirements discussions going in a GitLab board as well as in a weekly meeting. We'd love to have more folks participate in that. The Mass Open Cloud and the New England Research Cloud architectures are actively being defined. In the case of the Mass Open Cloud, the MOC redefined. Red Hat introduced their Operate First initiative, and they've joined this community. And Project Keras was proposed to address distributed compute and distributed storage. They've added a repository and posted their initial manifesto. Ways to help. Sort of the obvious ones. We definitely would like more people involved. We'd like a larger community. We definitely would like people to help us work on the technical gaps. Hardware is always lovely. We're really, really excited about the concept of creating a group of federated clouds that can share users and things between each of them. And obviously funding is always something that we look for. I never knew until I moved in from industry into academia how much universities roll on a river of cash. And here are some useful links on where to get involved. And these will be in the slide as well. If you go to the top level of either openinfralabs.org or massopen.cloud, you'll be able to find links to the OpenInfraLabs projects that are going on. If I was under 10 minutes, and I'm not convinced I was.
I think you are. I'm dying to hear your Ceph story. That was going to be my first question. So I guess I've seen your slides, but yeah, I think you have time. So let's hear it.
Okay, cool. So in 2017, we thought, let's triple the size of our Ceph cluster. And let's do it in August because everybody's away from the universities in August. What could possibly go wrong with that? So the good news is we did not lose anybody to a velociraptor.
That is good news.
Yeah. But let's get this out of the way. We lost all the data. We did a pretty good job of letting people know that there were no SLAs, so most users were okay, except for the MOC, because our website was running on a Ceph cluster and the VM was not properly backed up. And I'm happy to talk more about the specific things that we did there and how we did it wrong, but I'm curious if there are any things in the chat that I should respond to first.
Not yet. I think I would just say, yeah, tell us more about how you
so I will note
your Ceph cluster.
This is as reported to me because I wasn't involved at that point, which is not to say I would not have made worse decisions. I'm sure I would have. We weren't changing versions. We were just adding storage. We were doing upgrades via the failure recovery mechanism, where Ceph would redistribute the data. So you add a new OSD, you create a new map. Basically, the recovery needs to remember all the previous states. We figured that, so I'm looking at some notes now. I haven't talked to the folks who lived this recently. We were down longer than we expected. We needed a lot more memory than we needed, and we had quiesced. So the problem was we added too many OSDs at the same time, and they had too many placement groups. So we had a failure in rebalancing. Eric Olaf is smiling. So how did we fix it? Well, it was irrecoverable on its own. So we wrote a script with some help from folks in the Ceph community. In the original version of this slide, there's actually a blue thing that pops across with the names of all the people that we want to say thanks to. I'll just call one of them out off the top of my head, and that's obviously Sage, who was a huge help in some of this. He did not, however, write this script or review this script. So the script was going to manually do the rebalancing, but it had a bug where it deleted the placement groups. So all the data was lost. We started over from scratch, but this time we used supported bits. The other thing worth noting is this was in a storage appliance. And the storage appliance was an early day Ceph storage appliance, and it had I won't mention the partner it came from because it wasn't their fault. It had some non-standard placement group settings, and we learned a lot. And one of the things we learned was using supported bits makes life better. At least because there's more people to commiserate with when we had problems.
Awesome. Thank you. Yeah, I was just going to ask one follow-up question, which was from the chat. Colin asked if was a post-mortem write-up that folks can go read about anywhere.
You know what? I don't know, but I will find out.
Cool. That might be a good conversation for a future OpenInfra discussion. I know it's a great collaborative community, and I don't know if you all picked up on this at the beginning, but this cloud they're operating is for Harvard, MIT, UMass. I mean, there's all these incredible universities on the East Coast in the U.S. They're relying on this cloud for all kinds of stuff, different departments, fundamental research, things that we're all going to benefit from. as those breakthroughs come out of those incredible universities, the brightest minds. You know, all science is computer science these days, and they're relying on open source and Michael's team. And if we all get involved in their OpenInfra Labs initiative, we can help be contributors to those advancements by helping make the environments that the researchers rely on at Harvard and all these other great institutions, you know, make it all possible. So thank you all for presenting that. I know they're going to be able to stick around and answer more questions in Etherpad and throughout the event. And but at this point, I'm going to hand it over to Beth, who has already been participating. She's an OpenDev veteran to talk about what Verizon's been up to, and then we'll do Q&A after that. Thanks, Beth.
Okay, let me share my screen. Let's see, screen 2 is the correct one. We just set it up. This should do. Okay. Of course, now I can't see my own screen, so you'll have to tell me if it's correct. But I think
looks good.
Okay, done a few of these. So I'm going to be talking about some of the really interesting things that we've been that's been happening with our OpenStack implementation. We have a number of them actually, but this particular one, which is called the Verizon Cloud Platform, is used by our networking team for, among other things, the 5G deployment. But in this particular case, it's also used by our commercial customers. We provide services to our commercial customers to support networking applications. One of the reasons I asked the question earlier to the Blizzard folks was because in our case, these are applications that are not owned by us. They're from our partners. So it's a very different relationship with how it works with the underlying infrastructure. So I'm going to talk a little bit about, you know, sort of what the issue is, which is we have vendor applications that have very erratic and behavior on our cloud, what we did about it, and then I'm going to give a little user story for one of our customers. So here's the issue. So we have this lovely OpenStack infrastructure. It's distributed in 32 nodes around the world. It's all great. I'm embarrassed to say it's running on Newton, but whatever. And what we were seeing is the applications, again, which are not typically written by Verizon, but they're typically partners like firewall companies and SD-WAN companies, networking companies, those types of applications. And what we were seeing is that how they were configured had a significant effect on how they behaved in the environment. So, you know, if for example, one customer had turned on the encryption, all of a sudden the throughput literally halved. So we also found it was difficult to determine who was at fault, right? So particularly when we have service chains like firewall, routing, WAN optimization, all this traffic is going through all of these systems, and you know, it's like, okay, whose problem is it? We also found, unsurprisingly, that the vendor performance reports, which they did admit were done in ideal conditions in their labs, clearly did not work the same way in real life. And another thing that's actually kind of surprised me, some of the vendors were really good at optimizing to OpenStack, and others just literally did a lift and shift and did nothing to take advantage of the optimizations that are built into the OpenStack environment. So what did we do about it? What we did, and unfortunately, some of our customers were affected. So that's embarrassing, you know, when a customer turns on, who knew that a customer would want to send voice traffic through their firewall? Wasn't something we thought about, but now we ask them because one of our customers did, and immediately the performance went to hell. So what we've done is we have built a full production engineering lab with full testing capabilities. And we use it for both tier 4 and tier 3 problems, troubleshooting, as well as it's used for our by our development team. So that gives a really nice feedback loop. So a lot of the problems that are uncovered by our tier 4 team can be, fold back into what we, development efforts to improve the products, as well as, informing our sales teams. So for example, the example of the customer that ran voice traffic through their firewall, we now ask that question of all our customers. Well, what type of traffic are you actually planning to send through this firewall? Because, if they tell us that they're going to be doing something that is going to put stress on the firewall, we can configure it that way. But now we know, and because of the lab, exactly all the different nuances. Another thing that's important is we work closely with the vendors. So it's not just us, but it's also collaboratively with the vendors. So when we uncovered the fact that some of the vendors had not been optimizing to OpenStack, we were able to feed that back to them. And in one case, one of them had to substantially rewrite their application that took several months. But in most times it's not that extreme, but one vendor was pretty much caught with egg on their face. So moving on, just kind of take some lessons. This is a typical service chain that we run. This happens to be in the hosted environment, but we also have the other thing about our OpenStack implementation is we have the large nodes, but it's also on edge devices as well. So we actually test that in our lab also. And again, the effect of the network can have some significant effects on the performance in both environments. So our lab is able to look at both of those. So lessons learned. We verify any vendor comes in and says, this is how their application performs. We test it. We often find that, just encryption, for example, just changes the performance. There's a couple other things that have significant outsized impacts. We also test all the integrated service chains. So we actually have about 35 of them now. And one of the reasons why we don't have as many as we'd like, because the actual number of combinations is a couple hundred, is because we have found that we do actually have to do full performance testing on every single service chain. We have not been able to, we obviously have automated the testing, but it still takes a couple months for each service chain to go through, not just the testing of the service chain in our automated test harness, but also how it works in operations, setting off alarms, making sure everything all works. So that's a value to our customers, of course. And as I said, we do ask our customers to prevent unpleasant surprises. So I'm going to talk, and unfortunately, I don't have a clock. So Jonathan, you'll have to, or sorry, Mark, you'll have to kind of give me a little heads up.
Yeah, you're right on time. You're doing great.
Good. Okay. So I want to talk. This is a case study. This is a large financial institution. And they started seeing performance issues show up. It wasn't immediate because they weren't stressing the system, but in May of 2019, they started seeing weird behaviors. They started seeing low bandwidth and micro freezing of the application. And it affected it affected their security application, but it turns out that this particular issue affected all security applications. So we just hadn't seen it with other customers because this customer was the first one to stress things out. And in fact, what stressed it out is they started running their voice traffic through their firewall. They just had a standard policy that all traffic from within the company had to go through a firewall. End of discussion. So what we did about it is we made some changes to how the VMs were stood up within the environment. What's interesting is we didn't actually have to make any changes to the host environment, which means that we had actually configured the OpenStack correctly. We just were hoping that we could use, take advantage of not having to pin the CPUs, you know, and pin the VMs. We also, the SRIOV, we turned that on as well. Again, we had it, but it wasn't turned on by the vendor hadn't turned it on. And in one case, the vendor had to re-architect their VM to support it. So we are now standardly pinning all these VMs and making, we're looking at standardizing an SRIOV deployment for all future applications that we bring in. And again, this will all be, you know, this is all of the conversations we have with customers as they, you know, as with partners as they onboard in our systems. So this is just an overview of the throughput issue. So kind of bits and bytes here. It affected all the vendors except for one firewall vendor who had actually done it correctly. And all the SD-WAN vendors had also not done it correctly. It was particularly true of latency sensitive deployments, such as voice over IP. And it only affected larger transports. So under 100 meg or 100 meg and under was fine, and over a gig, it fell over. And 2 gig, I think we finally tuned it to some of them can support 2 gig, but most of them still can't. So we've turned off over subscription and improved the network interface. So here's just some sample of the guidance. This came out of our testing. We have we give these to the sales teams and the solutions architects so that they can guide the customers. And you'll notice I highlighted the one where it fell over. Now, in this case, it was because we turned on encryption. So we now, you know, warn customers, you will never get full throughput if you turn on encryption. And here's a SD-WAN application, sort of similar types things. Some cases it makes it through, some cases it doesn't. We use 3 different testing suites. And again, these are all industry standard type traffic testing patterns. And we take the worst case. We want to be conservative with our customers and you know, to make sure that they understand the issues. And just in summary, you know, customers obviously are looking to Verizon to, you know, for us to meet our SLAs. But, you know, unsurprisingly, customers do weird things with their applications. And we make sure to work with the vendors. That's something we can bring to the table because often our customers cannot have that tough conversation with, you know, let's say a routing vendor and a firewall vendor, and, you know, basically get together with them and say, okay, guys, let's solve this problem. So with that, I'm going to open it up to questions.
Great. That was amazing. Appreciate all the detailed examples. So one of the questions, Beth, that came in from chat or maybe on the Etherpad was, is it possible to reproduce all the customer issues in the lab environment?
It is, because the lab is connected to our production network. So in fact, it is the production network. In the case of that particular customer that we originally had the problem with the voice over IP traffic, they actually gave us a set of traffic. So they collected a couple hours worth of traffic. So we could literally duplicate their traffic. But we've also had customers where we fork traffic. So, you know, we'll take literally their production traffic and run it through the lab.
Good. Well, I think this might be kind of another spin on the same question, which was, do you test the applications on behalf of the users, which it sounds like you do, or do you offer
Yes,
the lab for them to test it, I guess?
We do not know. This particular lab is not one that the customers use. This is one we test for them. We do have other labs that customers can bring in their applications, but these are managed applications, so typically customer would not have access to it directly.
Okay, cool. Next question was, do you make changes for the pinned the pinned vCPU at the hypervisor level?
That's a good question. I think we do, actually.
Good. So I don't know if we have any other questions, because I think that we may have gotten to all of them. I think, you know, one of the things I know you're involved in with this event is you're moderating a session later this week. Can you tell us what session you're moderating and what you're expecting to cover in that session?
I'm moderating with Chris Price. I am moderating.
HA networking.
Oh, right. Sorry. I looked at it this morning. Yes, so I'm going to be talking about, so that's a great session. As you know, Verizon's a networking company, and networking has its own challenges, particularly around OpenStack, and actually even more so containers. So we're going to be talking about what does high availability networking mean in the context of software-defined networking. So pretty exciting. That's something that we've been working on pretty heavily within Verizon, not only for our customers, but also, of course, internally for us as well. So.
Good. And I know that we're already seeing with the earlier users, folks that are participating have added more questions, and the users have been answering them in the Etherpad. So, we're going to keep talking about the importance of Etherpads, but so much of the collaboration happens in there. So if you're having questions for Beth or for the other users, keep putting them in the Etherpad, and I'll keep signing them up for answering your questions. And it looks like we did have one more question that was actually for the Blizzard team, since we have a couple of minutes before our break. If Eric is still available, it looks like he's putting down his headsets. This is a good sign. So the question was, World of Warcraft, WoW, I think is the abbreviation, is generally has huge bursts in scale, like the classic launch, the World of Warcraft classic launch. What is the infra game plan usually like pre-launch? That was a question from Mohammed.
Colin, you want to take this one?
Yeah. Can you hear me okay? I'm
Yes.
muted here. Perfect. I just wanted to see the question. Whereabouts are we here? Is it in the...
I think it might have been in the chat earlier. So
in the chat.
Scroll back. Just preparation for a pre-game launch.
Yeah, perfect. Yeah. So, like I mentioned, we're very much multi-cloud, and for what that gives us is the capability to kind of hedge, right? You can kind of hedge for success, hedge for less than success. But we would run quite a part of our game instance workload in public cloud, and that gives us that kind of reach globally, but it also gives us that burst capacity. Typically, working with a game team, we work in scaling units, so we basically translate concurrently connected users into a pod of capacity, and we deploy based on I guess marketing data. It's all the usual kind of secret sauce that happens, but effectively we deploy more than we expect to use, and like whether it's through auto scaling or direct SRE involvement, we scale that based on a kind of day one launch day performance and behavior. Often, and a lot of games that operate today have different technologies to help protect the player experience. So for example, if too many players connect and you don't have enough capacity, and you see that all the time in the industry, you've technologies like logging queue, where users as they come through WAUT and through the kind of, I guess, the gateway services for that particular platform that you're running with. You know, the users get queued, you get a kind of comfort message, you know where you are, and very much that was almost a traditional classic experience, and became a bit more lore last year as people reconnected with the whole queuing experience, even within the game.
Okay, thank you. That's great. And I think, I'm guessing Mohammed must be a big gamer, because he has got a ton of questions for you. I know he's also a huge open infrastructure guy, but man of many talents. So Mohammed had a follow-up question. If you can disclose what was the biggest launch from an infrastructure side?
Biggest launch from an infrastructure side? Well, I won't get into too much detail, but Overwatch in 2016. Really because it was a departure from the traditional games Blizzard had operated, moving into the world of first-person shooters. You're moving into like running the physics sims on the actual game instances on servers that need to be close to players. So suddenly you transition from kind of more, I guess, less latency sensitive to extremely latency sensitive, and 120 frame per second competitive gaming within Overwatch requires quite a lot of infrastructure, quite a lot of network I/O, and proximity to the player base. And as part of our strategy back then that was a big push into multi-cloud, hybrid cloud, with consuming public providers to get us reach and proximity to players in geographies that we didn't own and operate infrastructure at the time. So yeah, it would have been Overwatch.
Wonderful. I know Overwatch is insanely popular, so that's awesome. So I guess one last question maybe for the Blizzard team is about your scale. I know we're talking about large scale operators. You mentioned some great numbers in your presentation, but maybe just to recap, how big is this infrastructure you're operating on?
Yeah, across all of our regions, and including production, development, and some of our different kind of non-production environments, is about 12,000 computes distributed globally, and that's across the Americas, Europe, China, Korea, Taiwan, and Australia also.
That's amazing. Well, thank you all. I want to thank the Blizzard team, the OpenInfra Labs team, and Verizon, Beth, for sharing these use cases, and for all the work you're going to do in the Etherpad next when we move on, because I know people have tons of questions and want to connect with you to work moving forward. And we have so many great stories today and many great sessions ahead. So I just invite everybody to take a quick break. We're going to take about a 10-minute break, and then we're going to dive into our first more roundtable style with Belmiro, our moderator. So we'll be listening to Belmiro. He'll be our guide through the wonderful journey of upgrades that, maybe he can help Beth get off of Newton. I don't know. So, sorry, Beth, that was a cheap shot. But anyway.
We are thinking about it, but we are telco, so we take things slowly.
Sure. No hurry. But when you want the person to talk to is definitely Belmiro and the team at CERN. So I think at this point, we're going to pop up the break slide, and you can enjoy a little bit of music if you're staying on, but we're going to be coming back at 7:30 Pacific, about 10 minutes from now. The time's here on the slide, 14:30 UTC. So in about 10 minutes, we'll be back with upgrades with Belmiro from CERN. Thank you all so much for joining. We'll be back soon. right. Welcome back, everyone. I'm very, very excited about our next session. I've been mentioning Belmiro from CERN earlier. They have so much experience with upgrades, and I personally just love the mission they're supporting at CERN. I was extremely privileged to be able to visit CERN last year, back when airplanes were still a thing, and the Large Hadron Collider. If you ever get a chance to visit, it's incredible. It's the largest machine that human beings have ever built. It's so big, it spans 2 countries underground, and they're trying to find that 95% of matter that's been missing. We don't know where it is. Mass, I don't know. I'm not a physicist, but I know a cool underground machine when I see one. So with that, I'm going to turn it over to Belmiro from CERN to moderate our next session, and we'll be using Etherpad and sharing that on the screen, and encourage everyone to get involved and listen to Belmiro as we go along here.
Hello, Mark. Hello, everyone. Can you hear me?
Sounds good.
Oh, great. Great. So it's great to be here today to talk about upgrades in a large-scale infrastructure. Let me share my video as well. Here we go. Can you see me?
Yep.
Yes, looks good.
Awesome. So my name is Belmiro Moreira. I'm a cloud engineer at CERN. CERN is the European Organization for Nuclear Research. I'm involved with the OpenStack community since the early beginning. So as Mark said, I will be moderating this session. Moderating a virtual session with hundreds of participants is also new to me. Of course, I need all your help on this. And this is a discussion roundtable. So please participate on this. So there are different ways that how you can participate. First one is the Etherpad. So we're gonna share the Etherpad in your screen. All right, it's right there. So please log into Etherpad. We have a few questions there. People start to populate with more questions. That is great. We're gonna follow up all the discussion on Etherpad, and is great for reference. Second, you can interact with us also using the Zoom chat. If you have a question, you can use the chat. Also, you can use the raise your hand functionality, and then you will be able to participate in the discussion. So let's start this session. To help me to trigger the discussion, we have 2 active speakers, Mohamed Nasser and Eric McCormick. So I will ask them to introduce themselves and talk a little bit about their deployments. Mohamed, are you there?
Hi there. Thanks, Belmiro. Good morning. Or that's the cool thing, is it's not good morning today for everyone necessarily. My name is Mohammed. I've been involved in OpenStack for quite some time now. I think the last time I checked, probably almost like 9 years at this point. Been running OpenStack in production, both in public cloud and private cloud context. And, we have some clouds that have been running around for a really long time. I think like we have a cloud that's been upgraded since Diablo and it's still running today, which is, really interesting and fun. I also sit in the OpenStack technical committee as the chair at the moment. And also I'm a OpenStack Foundation board member.
Cool. Hey, this is Eric McCormick. Sorry for the loud
Good morning,
video
Pedro. Catching up from being out for a little while. Hopefully I can get through all my email this morning. Planning on.
Whoopsie. Can you all hear me? Hello?
Yes.
No, yes.
We can
Oh,
hear you.
okay.
Can hear you.
All right. Sorry, I got somebody's somebody else talking into my ear. Yeah, hi. So I'm Eric McCormick. I work for a small MSP called Cirrus 7. We run a couple of OpenStack regions, mainly focused on doing application architecture for startups, kind of providing those cloud resources that are hard to get when you don't have your own internal technical resources. We also run some of our own data analytics products, partially in OpenStack, partially on bare metal. And we've been doing OpenStack. I've personally been doing OpenStack. I hadn't really thought about it until the Foundation Twitter question came out. When was the first OpenStack event you attended? And my first one was Portland in April of 2013. So just before. So the first deployment I did was Grizzly, I think, and been active in the community ever since. I work with, I started out doing Puppet OpenStack and manual hacky deployments. Actually started with PackStack, like many people do. And then Puppet OpenStack modules and into call Ansible. And I've used those tools to deploy a number of other clouds too. I do some consulting on the side. So I maintain a few clouds that are not my own as well, and have been successfully upgrading them now for a period of time. And I also, some of you may have been to some of the forum sessions I've run on this very topic from back in the more Wild West days when upgrades weren't quite so great as they are now. So things have progressed a lot. So that's pretty much it for me.
Great, thank you, Eric. So I'm going to also talk a little bit about the CERN infrastructure. It went into production in 2013. Today, we have 2 regions, 72 Nova cells, more than 8K compute nodes, and more than 5K ironic managed nodes. We run more than 10 OpenStack projects, of course, the usual suspects, but also Barbican, Magnum, Raleigh, Mistral, and many others. And most of the cloud is running Train in our case. I think that gives us a perspective how we should go through this discussion. We are here today to discuss upgrades because usually upgrades are seen by the operators as a hard thing to do. So that's why through the surveys, we are seeing a lot of deployments that are still running old releases. And this will be a way to understand why. So something that would be very cool today is to have a poll asking which versions of OpenStack are you running? And at the end, we can go through the results. So we'll launch the poll at the beginning. We managed to do that. And you're going to see the different options there about the different releases. Here we go. So please answer. And at the end, we will try to go through the results. Right. So something that we have been seeing in the surveys is that people are still running all deployments. It will be interesting to have your perspective. Why? So starting with Eric. Eric, you are running this discussion so many times in the ops meetups, also in summits. So why do you think people are still running these old and sometimes unmaintained versions?
Well, some of it is just the difficulty level of upgrading across versions. You know, starting, honestly, things didn't get to where it was, you know, I don't want to say easy, but, you know, a reasonable thing to upgrade every 6 months until fairly recently. So if you were on, you know, in my case, I was on Mitaka for a very long time. And the difficulty in it was just, you know, trying to get through one upgrade was really difficult. You know, being able to allocate the resources necessary to actually, you know, develop the orchestration necessary to do an upgrade and continue to run your cloud at the same time was difficult resource-wise. And once you fell behind, you were behind, and you have to go through every single version along the way. And that proved to be a major hindrance for people. So a lot of things got you know, improved along the way with things like Upgrade Checker, which will help you validate your configurations, and really primarily the work done by the orchestration tools. I think you know, Mohammed's team doing OpenStack Ansible, the Call Ansible guys, Juju, OpenStack Helm. I imagine, I haven't played with it, but lots of them have spent, many of the deployment tools work together and really concentrated on that upgrade process. Triple O, they did a lot of work in it right up front with doing the fast forward upgrades, which was a topic we discussed in, I guess initially in Sydney at the summit. it was originally called skip level upgrades, and that was termed an evil term because we're not really skipping, you're just kind of passing through quickly. But that didn't, that didn't used to be a practical option, and now in many deployment tools it has become that way. So I think anybody starting recently, probably since I don't know, maybe Queens, would be able to reasonably expect it to be okay to pass through more than one version. Still not the simplest thing. It still requires API downtime, but it's certainly a great deal better than it was a couple of years ago even. So thanks to everyone who put in all the effort developing the improvements on that.
Yeah, we will try to go through that later. Thank you, Eric. So sometimes in the OpenStack projects, we see these big jumps that you actually really need to upgrade a project. And it's a difficult upgrade. I'm thinking about Nova with introduction with placements or Cells v2, these moments where everyone needs to upgrade. Mohamed, so what do you think about these big jumps that everyone needs to follow? Would that be a reason that people are left behind?
Yeah, I think it's definitely a challenge. I mean, I very much remember our Cells v2 upgrade, and I think a lot of the larger operators definitely remember those. I think placement was a little easier, but I think it's kind of one of the challenges of wanting to provide the latest and greatest to our users, but also making sure that we do it in a way where service availability isn't kind of impacted. I think also a big part of it is a lot of people maybe play I'm going to wait and see what everybody else feels about how everybody else does the upgrade, and if they have other issues. It's like nobody wants to be the first one to upgrade. But then also at the same time, by doing that, there's kind of almost a stalemate where nobody wants to be the first one. So nobody really ends up doing it, or very little do it. But yeah, I mean, some were definitely painful. I mean, just to kind of remember, I think our Cells v2 took a really long time for the migration. And that's kind of part of why it's interesting when you're contributing, because we found out that there was a bug where it would only do 50 VMs at a time as it was migrating to Cells v2, which really was impossible for it to finish at our scale. And so we had to kind of go and make changes to the code while we're in the middle of an upgrade. So I think these are some of the experiences that might scare somebody the next time they want to do upgrade. They're like, oh my God, I don't know if I want to deal with this again, but I don't know.
Yeah, I completely agree with you. Thank you, Mohamed. Just would like to remind everyone that please participate in the discussion. If you want to join, just raise your hand and we will unmute your microphone. Of course, you can still follow on Etherpad. So moving on, because we see deployments moving much faster than others, this could also be to how they deploy their infrastructure. What are your comments on this? Because I see some deployments that have all the control in one node, one physical node, or three to be more resilient. And that can actually be an issue. Do you have some thoughts on that? Mohamed?
Yeah, I mean, so something that we've been doing a lot right now is actually moving a lot of running the control plane services inside Kubernetes. And what that has allowed us to do is it makes it a lot easier for us to prototype environments and see what the changes look like in a production environment very quickly. And also what it allows us to do is allows us to decompose the upgrades a lot easier. So we do upgrade one service at a time, for example. And when you're managing multiple clouds as well, it's really nice to be able to have the same exact set of configurations, the same exact read-only container that's running everywhere, versus something like when you're using an orchestration that, you know, might end up like, oh, you know, Bill changed this config at 3 in the morning 7 months ago when something went down, and now we just did an upgrade, and the state of the cloud is not what we expected it is to be. And so I feel like that's kind of one of the things that we've been doing, and OpenStack has been, because of how stable we are right now, it's been very easy to have mix and match of services. Like, so for example, in some clouds, you have like Keystone, Magnum, and Heat running a SURI, but the rest of the services are not there yet, and it runs just fine.
Yeah, you know, I think as far as
That's
even
right.
doing a, oh, sorry, hi, Derek again. Yeah, so I mean, running an HA control plane, I think has been, you know, one of the keys to having a successful upgrade strategy, because you can kind of pull one out and set it aside, you know, back up your databases and things like that, and then kind of tinker around with it. Having things containerized definitely made a big difference. I haven't yet tried to do things with Kubernetes. I'm just running straight Docker containers. But it does still, you know, allow in a moderate sized deployment to, you know, kind of move control plane things around, leave stuff active while you kind of set stuff aside and mess with it, without necessarily having to have a completely separate deployment. So that's been, you know, a useful thing for, you know, kind of trial and error, and also in particular rollback. You know, I have done, before I had Kala doing more, you know, nuanced upgrade orchestration. You know, I would pull a controller and a database server off to the side and not upgrade them. Just leave everybody running on, you know, running on the other two while I upgraded that singleton, and then cut everything over through load balancers to the already upgraded control plane, to kind of minimize downtime a bit, and, you know, allow myself some wiggle room if things blew up, which they often did. I ran into some cells issues too, but not so much the migration thing. I just ended up with all of my instances somehow magically being in a cell that didn't previously exist, not cell 0 where they were supposed to end up. So that was before V2. It was kind of like in that transition phase, kind of strange. But I ran into some things like that. I ran into some weird things where database migrations would fail along the way. Had some Cinder issues where, you know, I had one little problem in with my Ceph configuration, because I run Ceph as a Cinder backend, and it would just kind of not do the database migration, but it didn't tell you why it couldn't do it. So it was having, you know, so I was able to troubleshoot those issues kind of off to the side. So life with only a small deployment and one controller is really hard. Definitely recommend people run more than one if they can, even if you have to run multiple containerized versions of the same thing on, you know, other hosts that are used for other things or combined services. It definitely helps to be able to shift things around as you're doing upgrades and maintenance and things like that.
Yeah, exactly. That is another point, where people run this. In a containerized environment on VMs, physical hardware, that can also help a lot during upgrades. I can give our example at CERN. So we run basically everything in VMs that are managed by OpenStack itself. And then separating all the components through different virtual machines help us a lot during upgrades, because then we just focused in the upgrade of one component and not the upgrade of the entire cloud. Is there anyone else operating in this way? I mean, with multiple VMs or in containers?
I feel like that's an interesting approach. I guess my question back to you is, how have you worried about, you know, potentially if there's an issue in the OpenStack cloud, which then makes your VMs inaccessible, and you kind of have that, like, you know, the cloud needs to run in order for the control plane to run. How have you dealt if you had any issues around that?
We never run into an issue like that. Usually if the control plane is completely down, our VMs still have network. So we use bridge networking. And that is the main reason that we can run like this. We have some issues in the past because we also run some of the databases inside the OpenStack infrastructure. And we had some dependency issues when we needed to reboot the instance that was hosting the Neutron database. So you can imagine that was actually in the past a huge issue for us, because then the Neutron DB was down, which didn't allow to give that VM network at reboot time. But besides that, so now we moved that instance to a physical node. So there is no similar issue. But mostly we don't have any issue with this architecture where we run the control plane inside the infrastructure itself. This inception, as we like to call it. Does that answer your question?
Yeah, no, I think that is a good answer, and yeah, it could be an interesting thing, but it's obviously very beneficial because you can reuse the same hardware. But also, I find it interesting. I think Clark put in the chat, if anybody sees continuous deployment from master as a valid option. I'll start with hearing from you, Bhumira, because you're at a scale where continuous deployment might be a little hard, but maybe not.
Well, we never consider this option, running it from master. It's a little bit too risky for us. So we use the RDO distribution, and as soon the packages for an available release are there, so we start our upgrades. So currently we are running most of the components in train, and we start the upgrades to Zuri. I don't know, for our use case, it's not a very valid option. Because also lately with the latest developments, we don't get like that killer feature that we really need. We can actually just wait a little more months to get it. I don't know about you. I would like to hear others as well expressing their opinions.
I think the cadence of features has been reduced enough that it's running from master hasn't really been as beneficial, like to go through that effort in building the pipelines and everything else. I know when I first started out, that was the hotness. Everybody wanted to run from, you were running from master. Like Rackspace was like, oh, we run, from master. We build every day, we deploy every day. It's kind of it seemed like a great idea, but it's kind of terrifying and not necessary so much anymore as the bugs have reduced and the cadence of new required features instead of just nice to have or really cool features has come along. So I never had the time or resources to invest in building something like that, but whereas it used to be more desirable, I don't really find it to be quite so desirable anymore.
So have we reached a point where we can actually say that we can skip a version? What do you think?
It's not a skip so much as it depends on whether you're willing to have API downtime. That's still the trick. You still can't skip versions without an outage, which for some people is not practical. I can't. I don't know, Belmiro, you can tell me. I can't imagine that being an option for CERN, to take all of your APIs down to do an upgrade, but maybe it is. I don't know. I can probably get away with it, but it's not the easiest thing, I guess.
Well, is actually how we do it. We need to, doing upgrade, we need to put down the APIs to do it. There are some services that this is not actually really required. So last time in Glance, we didn't shut down the APIs. And everything went fine. It was basically almost transparent to the users. But there are some projects like Nova that definitely we need to do it. I'd like to encourage others to participate. I'd like to hear your opinion. I see that there are other big deployments logged in this conference call. So please just unmute yourself, raise your hands, and join the discussion.
Yeah, sure. Prakash here, if you can hear me.
Yes, perfectly.
Yep. So I think we did delve into this in the interop. And as far as you are within these 3 releases, the scope is definitely there for a jump. That is, you can jump 1 or 2, but beyond that, there is no what you call guarantees at this time. And especially, compute is the only one. NOAA is the only participating entity which ensures API interoperability, and that is at the level of what you call user APIs. But the administration API still may differ, and that's one of the catch-20s in the upgrades, I believe.
Right.
I noticed that Imtiaz left something in the chat about how they upgrade one component at a time as a strategy. Would you mind maybe talking a little bit more about that?
Sure. Can you guys hear me?
Yes.
Yes. Perfectly. Go ahead.
Yeah, so we are on Mitaka at OpenStack, like we're using Mitaka OpenStack at Workday. And what we found out is like our limitation for doing upgrades is like we have a short maintenance window during which we can do the upgrades. And if we try to upgrade all components, it poses a big challenge. Like not only it increases the risk of failure for any component that may go wrong, you're upgrading multiple database schemas and other things as well. So instead of doing that, what we started doing is to containerize all components first and then upgrade one component at a time. And when we try individually, it seems like one of the components go much faster. And not only that, like you can have your own schedule and we can upgrade one component, let's say within a given like 1 hour downtime. So that seems like a very like practical strategy for us, but let's a lot of the off-the-shelf solution or if vendor provided solutions don't quite support that option. So we had to develop our own tools to make that possible.
Yeah, I actually used to do, Sarek, I used to do the same thing when I was using Puppet for everything, and I was building my own orchestration layer and stuff. I actually used to do exactly that. I'd upgrade Keystone, and then I'd do Lance and Cinder, and then Nova last usually. But yeah, that definitely made things feel safer, and I could address a problem with a single service at a single time. Since I've been using other people's orchestration and just tweaking it to my own liking, I haven't done it as much, but that's definitely a really good strategy.
Yeah,
I'm curious, Imtiaz. Hey.
Oh, go ahead, Bomiro.
Go on. I was curious about what Imtiaz said about the containerization. I'm curious about the orchestration that you use for all of this.
We are planning to use Ansible for containerization. We have a little bit of like compatibility issues. Like our current infrastructure is mostly Chef managed. So we had to go with sort of a hodgepodge solution where the configuration is laid down by Chef, but the orchestration is done with Ansible. We're trying to move away with it. We were looking at Cola Ansible, but somehow we found like the architecture that the Cola Ansible expects is very prescriptive. We like used a slightly different deployment architecture, but we couldn't quite use it as is. So that's where we are at. Like I think I would like to think of it this as an intermediate phase before we can all switch to like fully to one solution and not have a like mixed one.
Sorry, just to chime in here. So Blizzard here. We went a very, very similar route as you guys. We containerized, we made our own containers, we did our own orchestration system using, well, we use Puppet and Ansible. Templatized all our configurations, and we upgraded them one by one as well, starting with we started with Keystone, then we did Nova, we did Glance, and then Swift, and then we did Nova and Neutron at the same time. And we didn't do containers though on the computes just because we found that too complicated. And we wanted to go Cola as well, but we had already made so many decisions in our history that it was very difficult to adapt, like the Kola deployment basically, but very similar otherwise, and worked great for us.
So now that we have Kubernetes and OpenStack Elm, is anyone considering that?
I mean,
well, we are considering that. That's why I'm asking about your experience as well.
We went the path of building a Kubernetes operator for OpenStack. So it pretty much is using Kubernetes, but rather than having kind of just Helm charts or yeah, pretty much just Helm charts or anything like that, we went the path of an operator because we wanted the ability of actually using some logic, right? Because we know all of these upgrades, there's a lot of logic. There's this has to go before that and whatnot. And that's hard to codify inside of a bunch of Kubernetes manifests. But in an operator, we're able to actually do something where we actually can embed logic into it so it can do the right thing at the right time, whether like if it's a cells v2 or whatever migration, then it would do the appropriate migration using containers inside Kubernetes. But also, I'm also curious, I noticed Javier left a comment that they can't upgrade every year as stability is important. And I wonder, I want to ask a little bit more if it's like the API level stability, or is it the worry that the data plane might go down, or is it the, just kind of curious what stability is in that context. If you can, and feel free to unmute and speak up if you want, Kabir. If not, then
okay. When you're ready, just please. Oh, okay.
Somebody a few minutes ago talked about it's safe. I'll read it out. Upgrading single services at a time makes things feel safer. Was there a and then we moved on to?
Oh, I guess that was me, Eric. Yeah, as far as like what I'm doing now, yeah, I mean I'm doing them all kind of as sequentially with you know, with call Ansible, just running the entire upgrade at once usually. When I was doing my own orchestration with Puppet, I generally did it one at a time because for safety and in case I blew something up, because the orchestration was all on me at that point, and I mean literally just me. So bugs happen, and my testing environment was small and not, you know, really adequate to test everything that I needed to upgrade. So it was definitely safer to segment and do it over multiple days and, you know, sleep in between and things like that. You know, now it's not quite as scary. I have more testing resources, multiple regions, so I can do, you know, I can do a smaller region to begin with, and, you know, try things out better. So it's less terrifying, and so I don't worry about it anymore. But I can definitely see it being a good, you know, a good strategy for especially larger deployments where it might take a really long time to execute an upgrade. Like, you know, especially those using Ansible, it's not, you know, it's not known for its lightning speed, in particular when upgrading like a crap load of nodes. So, you know, so I can definitely see segmenting it as a possible advantage still.
Thanks, Eric.
Thank you.
We're in the midst of using Puppet OpenStack in a very similar way to you're describing, and I'm hoping that means we can follow your path further along.
Yeah, sure. It's definitely still doable, and those modules are great, and have been, you know, have been for a long time. I just had some other requirements, but yeah, it should be totally doable.
Yeah. So as I say, we're using Puppet OpenStack in that way, but following along to using something like Collar Ansible looks pretty attractive.
Thank you.
Anyway, thanks.
So I also suggest that now we move a little bit through the questions that we have on the chat. So Asa Aloshari made a question about algorithms to calculate the number of nodes. I don't really fully understand the question. Can you clarify a little bit, Hassan? If you want to unmute. Okay, when you're ready, just raise your hand, please, if you would like to discuss this further.
Hello, sir.
Hey.
Yeah, I'm
Okay.
Hassan. I was asked a question about how can I know the number of nodes to deploy in my infrastructure depending on the physical server.
So
I think I can
talking
try
about
to help.
Can I, or any algorithm or something to calculate how number of a node I need to dependent on my physical server? Like if I have 10 server, how can I distribute the compute, like controller? How can I number of controller and number of other service? How can I distribute them between the server?
I think this maybe ties up a little bit to what some of the Blizzard folks were talking to. I asked this earlier about how they split their infrastructure on like how they have, you know, X amount of RabbitMQ machines and whatnot. But, you know, this is like one of those very, very interesting problems that I think if anyone had that magical answer for, you would make a lot of money, but no one has that magical answer for it. But most of the time, I would say most OpenStack deployments, if you want to have HA and you're something like at 10 servers, you're probably looking at 3 controllers that are running all of the OpenStack control plane services. And then the rest could be your compute nodes. That just could be an example. And to be honest, that probably can scale up to a pretty reasonable number where you just have 3 control plane nodes. The cases that we're talking about when users like Blizzard and CERN start to scale out their RabbitMQ and whatever, you know, you're going to be you're going to know when it's time to do that, and you're going to be kind of in a different position as kind of versus starting. So I would say there isn't really an exact number to answer that, but you know, generally the 3 controllers I'd say is the most popular choice until, you know, there's not really an answer. You just have to understand your environment and the way that it's built.
That is something that the large scale SIG is trying to answer. So cell, how can we scale a cell? What are the numbers? So actually we are asking for people to give their feedback and their user stories into the SIG, because that is very interesting numbers for everyone. And of course, because everyone deploys OpenStack in a different way, the numbers will be different. But at the end, we're going to get very important information and different considerations how to deploy the infrastructure. Thank you for your question.
May I ask another question?
Yes,
rudely. What is considered a large installation, and where do we start to see the scaling issues? Like if this is a large installation, big, like just about the scale we are discussing.
It's very hard to answer that because I think everyone has a different answer of what is large. Depending on your use case, 100 compute nodes could be extremely large. For others, 1,000 or 12,000, as Blizzard mentioned, are okay. But of course, sometimes when you scale, also you need to give up something. So don't expect in a very large infrastructure to have all the functionality that you probably have in a 10-node infrastructure.
Yeah, I think a big driver in this as well is how busy the cloud is. So for example, you know, we have clouds that are really large in terms of compute nodes, but they sit very idle and they don't do much. The VMs just run, so the OpenStack control plane isn't busy. On other side, we have clouds that are smaller in scale, but for example, see anything from 100 to 200 VMs getting spawned every hour. And so the work that happens in creating all these ports and creating all these VMs nonstop could have a huge impact on your control plane versus one environment that's sitting idle with a lot of VMs. So that pattern has to be also taken into consideration, which is like, how are you using the infrastructure?
Thank you. That is actually an excellent answer. And what I'm now wondering, do we have any indication on which factors contribute to the so-called, I'm air quoting, but it's hard to see, large scale, and how much they affect just for infrastructure planning purposes?
Like for X compute nodes, you need Y size control plane.
Pretty much, or for like 500 requests a minute, you need, it'll affect your control plane this much.
This is very hard to say.
Because there's so many different ways to connect all the building blocks in OpenStack. It's very difficult to produce a single document like that. And there's so many different approaches to even how people build their control planes. Like I think so CERN uses like the inception method of using VMs. We use all bare metal for our control plane. You know, currently we dedicate one function per bare metal node. So it's extremely difficult to extrapolate something from that.
I think that is perfectly the answer I was looking for. So the answer is there are no magical numbers lying around somewhere that I just haven't found.
Yeah.
Yeah, correct.
Engineer everything.
So as I said, we are trying to collect different experiences in the large scale SIG for people that have an idea, considering this deployment, the scale that they can reach. Thank you, Kyle. So continuing the questions that we have in the chat, there is one very interesting. Dishkshan Shavan is asking about the strategy for live migration when facing hardware issues. I relate this with upgrades as well, because we are only talking about OpenStack upgrades, but we also need to provide and do the OS upgrades, the operating system upgrades. And now moving from Python 2.7 to Python 3, and everyone upgrading their distribution, that probably is a big issue. So one of the models that people may thinking how to upgrade OpenStack to move forward now that Python 3 is required is actually live migrate instances to new compute nodes. But that means live migrate instances to new versions of QEMU, new kernel, many other things. So what are your thoughts on this? This is something that we have been thinking about, but having live migration between different QEMU versions, it's extremely hard that this model works. Do you have any comment on this?
So from an upgrades perspective, it's really a huge challenge in terms of like making sure that all of your different QEMU versions are all at the same time. I know that we're talking about kind of large scale upgrades in this case, and I think one of the challenges is if you deploy, you start with, let's say, an arbitrary number, a fleet of 1,000 machines, and then you add another 1,000, a year or two down the line. Generally, the kernel versions are maybe not going to be matching. A lot of things are not going to be matching from the first 1,000 batch to the other 1,000. And so a lot of times that's where you start getting to some really interesting issues with live migrations, not being supported back and forth. And I think that's where it can get really hard. Also, a lot of times I think the problem with live migrations is when you're trying to do upgrades, is there's a huge challenge in the testability of live migrations. And you can be in a situation where something happened 6 months ago, and that just locked an entire compute node or a set of compute nodes to not be live migratable. We just recently ran into this. We started having machines with host model instead, so we exposed the direct host model to the VM. But turns out the version of QEMU that we run blocks live migrations if the VMX flag or an SM virtualization is exposed, which means we have a huge fleet of servers that are literally not live migratable with like, and you couldn't plan for these things. They just appear and then they become a challenge in your upgrade process. And so those are the things that are, you know, very, very hard to resolve and figure out. And I maybe want to hear about other you know, operators that are here about, you know, this a strategy of keeping all your fleet consistent, even as you add more systems to your fleet to make sure that upgrades are happening easier.
From my perspective, I always have run with a custom CPU type, and I haven't used host pass-through for quite some time. I had some particular problems with I don't know if it was just an Ubuntu particular Ubuntu version, but I think it started with 16.04, where I couldn't even boot an Ubuntu instance on you know, the latest Intel processor because of some particular feature that it didn't like. I can't even remember which one. And then I got smaller batches of hardware as well, so I ended up, like you said, with, you know, a fleet of, you know, special snowflakes that couldn't take VMs from the other thing. So quite a while ago, I switched to just a custom CPU type with a kind of base level of features allocated to them, and you know, and ignoring what was actually in the box. I didn't have anybody that had a particular need for some bleeding edge CPU feature, but I suppose if I ran into that, I'd just make some sort of host aggregate of machines that, you know, could support that in kind of a smaller subset with a, you know, special flavor and whatever that would give them that CPU feature. But thus far, I haven't had that need. So.
Yeah, it's a very, very hard issue. We are suffering from this as well. And what I see now moving to Suri, that we need to also upgrade our distribution. That will be even a very disruptive upgrade, because probably we'll not be able to migrate to a different OS version, our current instances.
I also know that it's very early on the West Coast, but I would love to hear more from James Pennick about how they maintain their fleet to be as consistent as they can, because they also operate at a larger scale.
Although, J-Roll, are you on? Jim, I see you're on if you wanted to chime in here.
I'm here.
I wonder if you want to talk about what we're doing with Chef and what we're doing currently, and then if you also want to, you can also touch on what your next version of the architecture is.
Right. So currently we have just kind of a basic Chef deployment. We pin versions of our cookbooks, and we pin RPMs. Then we have our CI/CD system take care of bumping those pins as necessary and putting it through the testing phases. We're working on moving to containers. We've got the first container hitting production this week. And then we are also moving to like a Chef solo model. We're taking out the Chef server and just running Chef solo from each machine. And eventually we'd like to get into a model where we can reboot or rebuild a machine and have it automatically deploy itself at startup. And that way you erase any manual configuration you've had, you erase any just any state on that machine, right? And basically like giving it a fresh machine. Something we already do today is OS upgrades every 90 days. So that gives us a good opportunity for a fresh start right now, but we'd like to be doing that more frequently.
Thank you, sir.
Sure.
Thank you. So I suggest now that we focus on the Etherpad. We have lot of information there. How about we move to how to validate the upgrades? I think we touched the other topics a little bit. So are you guys validating your upgrades? We have some examples here. Gregorio, you'd like to talk a little bit about it? You add some lines in the header pads.
Yeah, sure. So we run chuck together a Terraform script that creates some instances and storage volumes and network things on a regular basis, and then we have that running all the time, and then we run it during and after upgrades to check that everything's still working properly. That's all we're up to so far. We want to deploy Rally, but we haven't got there yet.
Right. Someone else that want to talk about their infrastructure to validate upgrades? You're starting to have a lot of examples here. Don't be shy.
Just to speak on what we do, we have a Rally Prometheus exporter that runs Rally every 5 minutes and exports all that data out, which is scraped by our Prometheus. And so one of the things that we do is pretty much have Rally running against the cloud every 5 minutes with a bunch of SLA requirements that are codified inside Rally. And then we just make sure those are all always running and passing. And that's kind of a continuous signal of, have we broken anything or not yet? That can alert us every 5 minutes or so. So that's something that we do.
But you have like independent infrastructure where you upgrade, you run your Rally tests, and that validates your upgrade. That's it?
Well, no, so the Rally runs all the time. It's like almost a monitoring signal of the cloud. And the other kind of interesting thing is the upgrade is validated inside. The way that we're going towards is the upgrade is validated inside our CI. So Zool is actually building all the images, deploying the cloud entirely, running Tempest against it, and pretty much validating it as much as possible. And then after that, so by the time we're pretty confident when we go to the production that everything works, because it's tested with the same exact config in a virtual machine environment. And so Rally, I'm getting some questions about the Rally. So it's actually published right here on OpenDev, if anyone wants to use it. It's a little hacky. It reads like the SQL database, and there's some locking and whatever, but it'll run a task every 5 minutes, and I can share the thing that we run in a paste bin later.
That's something I've been looking for to have, like
in large Sorry, Eric.
No, go ahead.
I was saying that I think Rally is very popular in large infrastructures. We actually also run Rally. Every hour, basically, we have a very large set of tests that we run in our cloud to validate that everything is running fine. And for us, for the upgrades, we basically have a side cloud infrastructure, completely independent, where we upgrade the component that we are interested, and then we run all the Rally tests that we have, and plus other validation tests that operators do. That is the main feedback that we get for the upgrade, if it's okay or not. Eric, sorry.
I was just gonna say, yeah, if anybody has any jobs that are generic enough to contribute, to put an upstream repo for other people to use as kind of a model for how to build these things, then by all means, if you don't know where to put them, we can always put them in one of the OSOps repos, or feel free to contact me. I'm happy to help you share those things if you would like to.
Great, thank you. So at the beginning of this discussion, I asked you to fill up the poll for the versions. I think we're gonna end that soon. So if you didn't answer yet, please do it. Thank you. How about we move to, say again?
Address one of the database questions. on how everybody validates their database upgrades, and I'm wondering if what we do is a common process. We actually take, before our big upgrades, we take our dump of our production database and we run it through our devel system, through all the upgrade hoops, to see if it works. Because earlier we have had issues that we have had some UTF or other problems with our database, and on the upgrade day, our upgrade was slow because we had to firefight issues. And after that, we have always done a production database upgrade run before this, and this has proved super useful. We almost always find problems that we have to fix before the upgrade day.
Yeah, that is great. That moves us to the next question that we have on the Etherpad about the rest of the infrastructure, RabbitMQ, MySQL. Anyone with a war story about Rabbit?
I think going to the database question, yeah, I've seen these issues many times in the past, and that's usually when it's like an older database that's being upgraded. And a lot of times, yeah, it's UTF-8 and things like that. I don't think we've ever personally at our site done like a database dump in a simulated DB sync somewhere else. It's just mostly been fix it at the time that it shows up. But I think that's a really interesting thing that you bring up. And RabbitMQ, I mean, we have something that we call the magical playbook that we don't know how it fixes Rabbit, but it pretty much like re-bootstraps the cluster by reinstalling it. And somehow it works after. This has been an issue with like the 3.7 series. Moving to 3.8, we don't have that magical playbook needed anymore. But I mean, it's literally just called the magical playbook. We don't even know what we're doing at this point. We've tried to manually figure out what the deal is. But pretty much what happens is the OpenStack services refuse to consume the queues inside Rabbit. And even though Rabbit's holding that queue, the messages just keep accumulating. And no amount of restarting OpenStack services resolves it. The whole cluster, the whole RabbitMQ cluster being restarted ends up resolving it. And we haven't been able to detect any signal of figuring out why or how. But that's kind of for us with Rabbit. But 3.8 has been good to us.
Okay, so you have the magic playbook. Nice.
Yeah, the magic playbook is nothing but the OpenStack Ansible's like deploy playbook with a bootstrap flag on, and that's it.
So I think I can say that then we have the unicorn deployment decision at CERN. So basically we avoid to run RabbitMQ clusters unless it's extremely necessary. So in most of the cases, we only run with one RabbitMQ for the services. And that solves basically all the headaches of managing a cluster, even upgrades.
Are you running multiple rabbits per, I mean, you guys probably, for each cell and things, but per service? Like you run one for Nova, one for Cinder, or is it all just?
Yeah, that is an interesting point. So we have separate rabbits for each component. Of course, we have rabbit clusters for Neutron, for example, because all the loads. But for Nova per cell, we only have one RabbitMQ per cell, and that is an independent VM. And nothing of this is shared with other services. So Cinder has their own Rabbit infrastructure, Ironic as well.
We had actually talked about that in a session Mohammed ran over in Shanghai about doing that as a kind of a solution for some of the Rabbit headaches. So it's good to know somebody Huge is already doing that in production. So it's good validation.
Of course, we don't have a cluster, so we don't have high availability on that. But also we don't have the issues of the cluster at the end.
I think our goal, our goal here is we're trying to, as we're moving to the operator and running things in Kubernetes, we're kind of actually trying to move towards running a single stateless RabbitMQ. especially for things that are not going to involve notifications or anything like that. And we just kind of rely on Kubernetes making sure that that pod is always going back up somewhere else. So, you know, that's kind of our mechanism to rely and make sure that that RabbitMQ is running somewhere. So yeah, we're also thinking of, or not thinking, we're trying to move to that architecture. It's just right now we're in the middle of migrating things to Kubernetes, and our legacy existing Rabbit is still running.
You mentioned migrating to Kubernetes several times already, Mohamed. That is very interesting. We are actually interested as well. But there are still some limitations in OpenStack components migrating to Kubernetes because this application was not developed to run on top of container orchestration. I can give you an example. For example, Nova will try to create a service when it's running in one machine, meaning that if it's running in a container, every time something is replaced, we'll create a new service and a new service. Has been any conversation with developers about this? Do you know?
I think I haven't reached out at that point, but I think some of the workarounds we're thinking about for something like this is enforcing something like a daemon set that runs so that it runs on specific hosts that are going to be your control plane hosts. And so as we add more nodes that are tagged as control plane, that's where they run, and running it with something like host network on so that it actually gets the node host name injected. Another thing that we've actually been thinking about is using the node name, using the Kubernetes like API where you can expose it as an environment variable. And you can configure Nova using environment variable if you want to keep it running inside the, without exposing it to the host network. But, you know, I agree. There's challenges to be there, but I think there's a lot of value in moving towards there.
Yeah, I completely agree. So let's continue to move on in our Etherpad list of questions and topics. One question that we have is, what is the easiest and the more complex project to upgrade? You have a consensus here?
My vote is Keystone.
Complex or easiest?
Oh, easiest. Keystone's definitely the easiest because it's just an API with a database. It's just a simple RESTful API. It's scary because it's like the thing that everything depends on, but it's generally pretty easy.
I definitely agree on that front. Hardest one, I would probably say Neutron. I've somehow blown up Verizon multiple times, so I really don't think it should have been that hard. But I've managed to nuke it more than once. But yeah, besides that, probably Neutron, even more so than Nova. And if you're running any kind of funky plugins or something goes haywire in a bridge config that takes stuff out, there's just a lot of moving parts Neutron-wise that can cause problems. Not anything wrong with Neutron in particular. There's just a lot of things going on in there.
Yeah, completely agree. All right, so please give your opinion. That is pretty interesting. If I need to vote, I'll vote in Nova for the more complex, but probably that is related to the size of the infrastructure that we have.
Having ironic layered in there probably adds complication for your site as well, I'd imagine, doesn't it?
It's more related with Nova, the complication, because ironic, you have the API, and then you have all the interaction with the Nova API, with the Nova compute node. And scaling that, it's a little bit tricky, and we have been learning a lot and actually sharing our experience regarding conductor groups and what we are doing. All right, so what are the changes that you would like to see in the future? So a lot have been improving. So the first upgrades that I did a lot of years ago, they are completely different now. What are the main challenges that's still remaining? So the developers are doing a great work easing all this path, but what do you think that can still be improved? Any take on that?
Yeah, I mean, from my perspective, I would still someday like to see a true skip level upgrade. I don't ask for it anymore, but I think it's been, I would love for it to happen one day if we had the bandwidth and developer resources to actually make it happen. Zero downtime, multi-version upgrade would be great, because we still have a lot of people who it's too much to bite off. Upgrading even once a year sometimes. And it would be nice for them to be able to catch up without having to hop through, long outages and things like that. So long term, I would really like to see that. And potentially, we've talked before about, slowing down the release cadence at some point, now that the requirement for, critical features is not quite so great. So I think that sometime that might be a discussion worth having. Could also help people not get so far behind and really plan around a longer release schedule.
Yeah, I completely agree with that. I think that having upgrade without API disruption is already possible in a few projects. If they don't change the DB schema, that is basically possible. We did that with Glance in the past several times. However, with projects that also involve messaging, that is much more complicated, like Nova. Any other comments on this?
How about better rolling upgrades?
Right.
Yeah.
Go ahead, Eric.
No, I agree. Rolling upgrades would be another way to do that, right? Some projects are kind of more geared towards that than I know Nova, and for example, a lot of the lazy database migrations and things like that going on. There's work in that area. It's still not a multi-version thing. It's still end-to-end plus one. So I would, sometime like it to see it be more than one version, at least N plus two update.
It's also important in the edge, rolling upgrades in the edge, because you can't upgrade everything all at once.
Yeah.
Right.
I want to make I noticed John had their hand up. I'd be curious to hear what they have to say.
Oh, hey, yeah, I raised my hand because I was going to ask a question about if anyone's actually tried leaving the Nova API on during the upgrade, and actually tried the role, because the Nova upgrade was also very much designed for allowing to have older computes running for a while. So the idea is the API could get done first and then leave your computes if you've got lots of computes to do behind. I'm curious what people's experience of that is.
You're talking just for a single version upgrade. I leave it on all the time. I don't ever turn it off for a single version upgrade.
Well, I guess I'm using Color Ansible too, so I'm using the same same
well,
logic to do exactly that, right?
Yeah.
So I concur, but perhaps because I'm using the same code.
Yeah, I mean, I did it with Puppet too, even back, from the time they first put in the what was it? I can't remember what the config flag is called.
Online schema migrations.
Yeah. So you could tell the computes that they were tell the API that it had old computes. Yeah. So you could tell the thing you were to allow old Nova computes and then just leave it running. So ever since that came in, like Juno or something, I've been using that.
Cool. I was just wondering if anyone else
I'm not using that. I think it's still too risky. When you have a lot of components with a lot of cells behind, it's a lot of control plane.
Yeah, I mean, in terms of the n to n plus 2, I think it's also risky in terms of the testing matrix, right? So there is risk there for sure.
Yeah.
Depends which route you test through the journey. Don't know if anyone else has experience on that.
we've generally tried to turn things off, but another open question I'd like to ask for everyone is, has anyone used the upgrade, I forgot what we call them now, upgrade checkers? Has anyone taken advantage of upgrade checkers as they upgraded their cloud? So that's the like Nova Manage, I think upgrade check, and then all the other services also added a couple of upgrade checkers.
Well, I think it's very nice that we have that in the codes. It's something that we used it last time, but it was something that we are already doing. So it was in our tools, so it was nothing new for us. Because the upgrade checkers basically checks if you are running the latest version of your database schema. Any other take on that? Okay. I think we move on then. Mohamed, was that okay?
Yeah, I mean, it's. I guess maybe people can leave it a little bit later in the Etherpad or in the chat at any time.
Okay, so I'm gonna end the poll now. I expect that most of you already voted. Actually, yes. So here you go. Can you see the results?
Yeah.
So this is actually pretty cool. So most of the people are running Train. Already 7%
yeah, but
running CERN.
significant other things, and I didn't get the vote for some reason, and I'm on Newton. So with
you are represented as well, even if you didn't vote it.
Okay.
Newton is still in the list. Can you all see the results?
Yep.
Yeah,
They popped up on my screen.
It's actually pretty great. We had the discussion in at the Ops meetup in London about how this sort of poll has shifted. We've if you go back and like pull up the Ops meetup wiki and look at previous Ops meetups, there's always this poll, and I would say since since Queens and later, this thing has definitely shifted towards the newer side.
Well, that's good.
There's still an ice house or an ice house and a kilo floating around out there, I think, from the last one, but there used to be 0 on the latest version and maybe like 1 or 2 on the N-1, and then it would start to balloon out as you got back towards Mitaka. There was a big block there between Mitaka and Newton for a long time.
Yeah. Well, we went from kilo to Newton, but I don't know. I think I know there's rumors that we're moving to Queens or Rocky. So.
All right.
It's certainly way better than the earliest user surveys were. I remember those, and there was a lot of caution about upgrading.
Yes. What was
terrifying.
Yeah, what was that company that was stuck on Cactus? Was one of the eBay subsidiaries. It was stuck on Cactus for years.
I know there was definitely a couple of Essex ones floating around out there, even up until a couple of years ago too. I can't remember who it was now, but I'm sure I could go back and find that and stick it on the Etherpad just from one of the old Ops meetups.
Right, but actually, what this means is upgrades are actually working and people are actually upgrading. So I suspect that upgrades are actually getting easy for people to do this operation.
Yeah.
So
we've our newer clusters we found have been much easier to upgrade than our older ones. So we used to get stuck way back in versions, and a lot of getting stuck back in time was actually due to all the patches that we put in. So the more we patched things in, the more we were kind of stuck, and the larger effort it was to move forward. But it seems like it's gotten a lot easier with, especially there's stuff that's running Rocky and above.
Right.
Well, but
So-
we also have a number of different versions in the company, right? So we have at least 3 or 4 that I know of.
Yeah, for sure. But even those newer clusters James mentioned are a variety of versions, just due to, we upgrade single components as well. So we have some stuff on Train and some on Rocky in there.
Right.
All right. So we are trying to wrap up the session. We have 15 minutes. And actually, Panic touched a very good point about custom patches that everyone has. And they are actually a pain when we are trying to upgrade, because we need to then to migrate that to a new version, test that ourselves. So I'm curious, what's your take on that? Are you still running custom patches in your clouds?
Oh yeah, yeah. We still have a lot. Our newest clouds have far fewer patches, but for most of our stuff, just because we are running such large clusters it's really not about the size of the cluster. It's about the type of use cases we're trying to handle. So some of it is, tying in with internal asset management systems. Instead of someone boots an instance, we need it to go into an asset management database, just so we're aware of who is using that asset at that point in time. And while our goal is to, over time, change the way we've been interacting with these things, we still do have quite a few patches. But every upgrade, what we're trying to do is, as we work with the community to share some of our experiences and get things into OpenStack, we're also then trying to, as we upgrade, start pulling all of our custom patches out and changing the way that we have patched things into OpenStack into being more maintainable, more driver-based or plugin-based, whatever possible, or even ultimately for some things, Jim's had a design for moving some things to actually just react to messages coming across the queue. So that's sort of the end game for us, and the sooner we get there, the better. But I will say, I guess, just sort of as almost like a soundbite, that I've only ever regretted not getting something upstream, but I've never regretted the inverse, right? I've never regretted working with the community to get something upstream, because it always makes things a lot easier for us.
Any other take on this? So in the past, we had the discussion to have plugins in an easy way into OpenStack to be easy for people to add their own patches. I think that died a little bit. Well, we have plugins like in CERN, but for example, in Nova, actually when it's a custom patch, it's a custom disruptive patch. Could that be a way that the community could follow to solve this? Everyone have some kind of custom patch?
Can I chime in there? So
Hey, go
Eric
ahead.
from Blizzard again. Yeah, so for we carry very few patches now. In Mitaka we carried a ton of patches, but we upstream most of them. The majority though, if we have anything now, it's plugins. The only exceptions would be exactly like with Nova, for example, the scheduler filters. They might be pluggable now, but that's one of the areas where we couldn't make it plugins in Mitaka at least. We kept them downstream, but making it pluggable would have removed any need for us to do any changes to actual code base, which is awesome. And I hope it's a pattern the community follows more, because plugins is great.
Yeah, it's a lot cleaner. I was wondering if having the extended maintenance in place, having branches open longer has resulted in more people upstreaming their changes. I don't know if anybody's got any visibility into changes landing in stable branch, like beyond when they used to expire. I know we used to have a lot of people that carried patches and ran their own CI, their own third-party CI, because the branch was EOL upstream, and they didn't even get to that version upgrade-wise until it was already EOL upstream. So I'd be curious to see. I have no visibility into it, but I would like to see if sometime if any more patches have landed towards things as they go into EM, or if it's just silent and dead.
So what I see today is that most of the extended releases that we have no maintainers. right? So I think the last one with maintainers is Stein, which actually it's quite new. All the others don't have any maintainer or contributions, I mean.
Well, hopefully that means that people don't need the batches there, but it may just mean they don't know that it's there either. Or know that they can still contribute things back upstream to it, or they don't know how. Be interesting maybe to kind of put something like that out there, like super user article on extended maintenance and how you get something in there if you're carrying a custom patch that would benefit people.
Right, that will be great. So we have less than 10 minutes. I'd like to wrap up this with the war stories. Most of us are operators doing OpenStack for a long, long time. So what are your war stories with upgrades? Do you have any? I imagine so. Who wants to start? No one.
I could share a war story about upgrading at the edge. So we had, we found there was some specific things that required us to do upgrades at the edge, because at the time, and that's been fixed, and part of the reason why we were doing it was we couldn't do upgrades while the system was still working. We couldn't do like a download and then a cutover. So the upgrade required like 3 hours of downtime to do it. It was really painful. So we had to do it with maintenance windows and a whole bunch of pain, and it required like 6 reboots to get it to all do it. So that was a war story.
Well, I can share that we did one upgrade that we didn't notice, or we only noticed that we upgrade after we did it. So that was the easiest upgrade ever. Once, this was a few releases ago, we upgrade to it because we are trying to test the new it version. We deploy a new virtual machine, as we always do. However, that virtual machine was connected to the main database. And of course, testing the upgrades, you do the sync, and then going back is quite difficult. So that is one of our war stories with upgrades. That was very fast and upgrade.
An upgrade so easy you didn't even know you did it.
Well, we noticed later.
I guess my most recent one was the one I went from Queens to Rocky. I recently started running Octavia for things, in particular for as part of heat stacks for OpenShift clusters. And I didn't realize, still learning things about Octavia, but custom, basically you have to go and build your image for your load balancers for your HA proxy instances, just using disk image builder, and then put it up there and add it in as a, add in the UUID to the configuration so it knows what to spawn. It's apparently much more finicky about what version of that VM or that image you're running. And when I finished the upgrade, it looked pretty good. My APIs were all working, and then people started screaming that their lights were down and things started ringing off the hook, even though all the instances were still running. And then I noticed that every single one of my load balancers was in a deleting state. and nothing was. I had no VMs whatsoever, so I just nuked all of the load balancer instances and could not respawn them because there was an incompatibility with the image that I had. So I very rapidly built the new image and stuck it in there and reran the Octavia config to change that UUID, and they all magically came back. But that was my most recent upgrade panic attack, I guess.
Yeah. I have one interesting one relating to Octavia. This was working with a customer where we got them up to train And so this was like a ticking time bomb that we didn't know about. And so what Octavia does is every little bit of time, I think every like 30 days or so, it goes and renews the certificate that it uses, because it uses public-private certificate authentication to talk to the amphoras. The issue was the amphoras had a bug inside them where there was like it was a Python 3 related incompatibility. So it's like one of those things where you just have to like parse it as a string because it comes as bytes or something along those lines. And what would happen is, everything is working fine. When it came time to do the renewal, it would go make the request, ask the amphora to renew its certificate. It would crash in the middle of renewing its certificate, and then the amphora becomes unreachable anymore because the certificate that's stored is completely invalid. And now, the Octavia can't talk to that amphora instance anymore. And because it can't talk to it, but it still thinks it's alive, it's failing to recover from it to like turn it off manually. And then this is one of those things where like it happened with 1, then happened with 3, then like 5, and then like slowly they would just drop off every time you hit the 30-day mark, until we finally discovered the root cause was. And so it's definitely interesting because it's one of those things that only with time you end up starting to realize what the issue is. And it puts you in a locked position where you can't get out of it once one fails. So that's a fun one.
Yay. So I suggest that we go quickly through the comments and some questions in the chat. So Tim Bell and Eric Olof mentioned Python 2 and Python 3 related with the versions, OpenStack versions that people are running. I think we touched a little bit of that when we talk about live migrations. Then about plugins, I see Pierre that mentioned with Blazor that they are pluggable. And Anastasius mentioned Octavia, the certificates expiration. I don't really get it. Anastasio, if you have a few seconds if you want to give more information.
Yeah.
Okay. Okay, so we are ending this session. Thank you so much to everyone to participate on this. We have the other pod. Of course, we didn't touch everything that we have here. I think we can follow up all of this now during the following days. Thank you so much for your participation. I'd like to finish, especially for the active speakers and considering all your experience with upgrades. You have any advice for OpenStack operators that are starting with OpenStack? Few words.
It's really not
embrace your inner upgrade.
Yeah, I always advise new people new to OpenStack to do a manual install. I know the install guides have, maybe need a little bit of work, but figuring out what's wrong with them is part of the fun. So learn how each component actually works. So when it breaks, you know how to fix it, because it probably you'll probably break it at some point in time. But do embrace one of the deployment tools because they are fantastic. But I definitely recommend like learning the inner workings of it before you jump headlong into a production cluster.
Also, Belmiro, before we drop, I think Ashley was going to share a little bit of a summary and a couple of next steps for tomorrow, if that's okay.
Oh yeah, I definitely will pass to you. That was the goal.
Oh, awesome. Well, I'm passing it back to Ashley, but thank you all so much. It's an amazing session, especially Belmiro and everybody who engaged. And I think Ashley is going to summarize a couple of points.
Yeah, so thanks everybody. Thank you so much for joining. Thanks to all of our user stories presenters from Blizzard, OpenInfra Labs, and Verizon. We had amazing attendance today. We even had people from Sudan, Nepal, Costa Rica, We got over 100 responses for the what version of OpenStack are you running poll. Most of you are running train, so that's really interesting to learn. And we're always looking for this sort of information, so make sure that you take the user survey when you have a chance. I think we're dropping the link in right there. Yeah, so we're always looking for information. It's critical. Another place that you can share that information is in the large scale SIG. So if you're interested in joining that, make sure to visit that wiki. We'll also drop that in the chat right now. So that's a great place to connect with others and to continue these conversations. You know, obviously this ran long, and that's what we want. So we want to direct you to a place to continue these conversations. And if you're interested in connecting with each other, feel free to drop your contact info into the Etherpads that we've been using today, if you are comfortable with providing that and with people reaching out to you. So use that as a resource for sure. And then also we will drop an Etherpad into the master list of Etherpads, Etherpad Inception, so that you can see what's coming up for tomorrow. Jump in there, explore those a little bit. You know, just so you know what's coming up, drop your name in there so that we know to look for you if you're interested in hopping into any of those discussions. And shout out to Gregory and Hassan and Kala for joining the discussions today, and James. That's exactly what we want to see, and we love that. So yeah, so jump in those Etherpads. And there's also an Etherpad within that Etherpad to provide some feedback if you have any suggestions for how this event could be improved in the next couple of days. So yeah, and I'll turn it back to Mark to let you know what to look for on Tuesday and Wednesday.
Yeah, and so we have a list of additional topics coming up in the next couple of days. And, you know, we're talking about the tools, high availability networking and software stacks tomorrow. The link we're dropping in chat will take you to the schedule where the Etherpads are. So if you haven't learned by now, we love Etherpads, and we want to keep giving you the link so you can participate. And then, of course, Wednesday, bare metal is an exciting topic that I know a lot of people are interested in these days. Edge computing, of course, and then we'll be wrapping up the whole week on Wednesday. So with that, I just hope that you all had a good time with OpenDev and look forward to seeing everyone tomorrow. So thank you very much. Appreciate it. That's a wrap. Bye.
Thanks, Al.